Good morning, good afternoon, and good evening, ladies and gentlemen, wherever you are. It is my pleasure to officially welcome you to workshop Electric Bus Deployment, Technology Selection, and Business Models, Tuesday, 31st August 2021. And my name is Vania Fitrianti Herlambang, and I will be the moderator for today's event. So the government of Indonesia has been promoting a sustainable and clean transport system by issuing the Presidential Decree number 55/2019 on acceleration of battery electric vehicle programs for road transportation in 2019. To support this, the World Bank, with funding from the Mobility and Logistics Trust Fund and the Energy Sector Management Assistance Program, has embarked on a technical assistance on e-mobility adoption roadmap for the Indonesian Mass Transit Program in the urban areas of Greater Bandung and also Greater Medan. In the previous workshop held on 2 to 3 June 2021, we have already discussed about the global trends and also several case studies from USA, Europe, Chile, Bogota, and also Shenzhen, and how to leverage those lessons learned from USA and Europe climate policies to bridge the policy gaps to expedite the adoption of e-mobility in Indonesia. And now, the objectives of this second workshop are to understand how to select the battery electric buses and charging infrastructure technology to be deployed in a city, and also discuss the potential business models to finance and also operate these systems. Now, I would like to explain our house rules for today. When entering the workshop, please click Join Audio, and then kindly press mute your microphone and also turn off your video while you are not speaking. Please access Zoom from a stable internet network. While you are speaking, please make sure that there is no background noise. And also avoid accessing this workshop nearby other users because it may cause echo or feedback noise. Should you have any question, please feel free to write questions directly in the chat box. This event will be fully conducted in English, and we have an interpretation feature from English to Bahasa or vice versa to assist all participants for today. This is how you access the interpretation facility by pressing the interpretation button on the right bottom corner of your screen, both from your laptop's PC or your phone device, and then you can choose English or Bahasa for your preference. Before we start, I would like to explain our agenda for today. First, okay, so I would also would like to remind again our house rules, ladies and gentlemen. Please note that to ensure the smooth running of the workshop, the host or co-host reserve the right to first mute the audio of participants who are not speaking that may be unintentionally causing disruption to the workshop. This is to ensure that the audio of speaker and interpreter remains clear at all times. Thank you very much for your understanding and cooperation in this matter. So before we start, I would like to explain our agenda for today. At the beginning, we will start our program with welcoming remarks from Bapak Budi Setiadi as the Director General of Land Transportation, Ministry of Transportation of Indonesia, and also from Benedict L.J. Bergen, Practice Manager, Transport, East Asia and Pacific, the World Bank. Following that, we will have keynote speech from Bapak Firdausi Manti as the Assistant Deputy for Maritime Industry and Transportation, Coordinating Ministry for Maritime and Investment Affairs, the Republic of Indonesia. For the opening session, there will be Francisco Posada as a Senior Researcher at the International Council on Clean Transportation. And then we will commence our discussion. In the first module, we will discuss about technology selection and infrastructure planning on e-bus deployment. And then in the next session or the next module, in the second module, we will discuss further about the business model and also financing mechanism on e-bus deployment. And after each session, our speakers will answer your submitted question about related topics. And this event will be closed with a closing remarks by Rahul Gupta, a Senior Urban Transport Specialist, the World Bank. To start our agenda, I would like to invite Bapak Budi Setiadi as the Director General of Land Transportation, Ministry of Transportation of Indonesia to the stage to give a welcoming remarks. Bapak Budi, waktu dan tempat kami silakan.
Baik, Mbak Fania. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera bagi kita semuanya. Om Swastiastu, Namo Buddhaya, salam kebajikan, dan salam kesehatan untuk kita semuanya. Yang saya hormati, Mr. Rahul Gupta dari The World Bank, dan juga yang saya hormati Mr. Benedict Elbergen, Practice Manager dari The World Bank juga. Kemudian saya hormati pula Deputi Infrastruktur Bappenas, Kepala Badan Kebijakan Fiskal Kementerian Keuangan, Deputi Bidang Koordinasi Infrastruktur dan Transportasi Kemenko Maritim dan Investasi, Dirjen Industri Logam, Mesin, Alat Transportasi, dan juga Elektronika Kementerian Perindustrian, yang saya hormati pula Dirjen Ketenagalistrikan, Kementerian Energi dan Sumber Daya Mineral, kemudian saya hormati Dirjen Bina Pembangunan Daerah, Kementerian Dalam Negeri, yang saya hormati pula Direktur Pengelolaan Dukungan Pemerintah dan Pembiayaan Infrastruktur dari Kementerian Keuangan, kemudian saya hormati pula Direktur Mobilisasi Sumber Daya Sektoral dan Regional Kementerian Lingkungan Hidup dan Kehutanan, serta Direktur Utama PT PLN, dan juga Bapak Ibu sekalian hadirin sekalian yang saya hormati. Puji syukur kita panjatkan kehadirat Tuhan Allah yang Maha Tuhan yang Maha Esa, Allah Subhanahu wa Ta'ala, atas limpahan rahmat dan kesehatan kepada kita, sehingga pada pagi hari ini kita bisa berkumpul untuk mengikuti kegiatan workshop yang diselenggarakan oleh The World Bank dengan tema EBAS Deployment Technology Selection and Business Model. Bapak Ibu sekalian, kita ketahui bersama bahwa polusi udara menjadi permasalahan pada kota-kota besar, termasuk juga di Jakarta dan juga kota besar yang lainnya di Indonesia. Penyebab utama dari polusi udara tersebut adalah asap pembuangan dari kendaraan bermotor. Dan kita melihat juga banyak penelitian yang dilakukan, 75% diantaranya bahwa polusi udara diakibatkan karena gas buang dari kendaraan bermotor. Dan salah satu upaya yang dilakukan untuk menurunkan tingkat polusi udara adalah dengan peralihan dari kendaraan bermotor dengan motor bakar menjadi kendaraan bermotor listrik. Dan pemerintah sudah membangun beberapa regulasi dari mulai Perpres 55 dan juga beberapa turunan peraturan menteri, diantaranya juga peraturan Menteri Perhubungan, Menteri Keuangan, dan sebagainya, sehingga ada percepatan akselerasi baik dalam rangka memproduksi maupun penggunaan kepada masyarakat. Dan kemarin saya juga baru saja dengan Menteri SDM untuk melaunching bengkel konversi kendaraan dari mesin ke listrik. Dan berikutnya, dalam rangka percepatan penggunaan kendaraan listrik terus dilakukan sesuai dengan Peraturan Presiden Nomor 55 Tahun 2019 tentang percepatan program kendaraan bermotor listrik berbasis baterai untuk transportasi jalan dengan proses percepatan implementasi roadmap dengan tahapan. Jadi kami sudah dengan Kementerian Menko Maritim sudah membuat roadmap untuk penggunaan kendaraan bus perkotaan listrik. Dan kita harapkan setelah bus perkotaan secara bertahap nantinya bus antar kota, antar provinsi juga bisa kita lakukan dengan kendaraan bermotor atau bus listrik. Jadi yang pertama roadmap yang sudah kita diskusikan dan sudah kita usulkan, mudah-mudahan dalam waktu dekat akan segera mungkin dengan surat edaran atau dengan SE dari Pak Menko Maritim, sehingga nantinya bisa dijadikan sebagai rujukan bagi kementerian-kementerian yang lain untuk juga bisa mengimplementasikan kebijakan ini. Yang pertama adalah kendaraan dinas operasional pemerintah pusat dan daerah, serta TNI dan kepolisian yang berbasis listrik. Yang kedua adalah untuk angkutan umum massal, yaitu BRT melalui program BTS untuk angkutan umum perkotaan, kemudian angkutan umum bandara, angkutan pariwisata di wilayah KSPN, dan juga berikutnya tahapan terakhir nanti adalah angkutan antar kota, antar provinsi. Dan tahun 2021 ini, 2 BTS dari Kementerian Perhubungan, yaitu ada di Surabaya dengan di Bandung, diantaranya 2 koridor di Surabaya, 1 koridor di Bandung, kita akan menggunakan kendaraan bus listrik. Kemudian berikutnya adalah pemberian kemudahan fiskal dalam penggunaan kendaraan listrik, pelaksanaan konversi sepeda motor dari motor bakar menjadi motor listrik sesuai dengan Peraturan Menteri Perhubungan PM 65 tahun 2020 tentang konversi sepeda motor dengan penggerak motor bakar menjadi sepeda motor listrik berbasis baterai. Untuk roda 4 ke atas sedang disusun regulasi dan tahap uji coba kendaraan bus oleh Damri. Kemudian berikutnya juga adalah persiapan pembangunan SPKLU ramah lingkungan oleh Kementerian SDM dan juga PT PLN dengan rincian sebagai berikut. Yang pertama dari Kementerian SDM, rencana di tahun 2021 sekitar 572, tahun 2025 sebesar 6.318, dan tahun 2030 sebanyak 31.859, existing nantinya ada 147 unit. Kemudian PT PLN juga sudah merencanakan tahun 2021 ada 168, kemudian tahun 2025 sekitar 1.558, dan tahun 2030 sebanyak 6.082. Kemudian berikutnya kendaraan listrik dukungan untuk pertanian dan perkebunan, angkutan sampah, dan SPKLU yang ramah lingkungan. Dan ini sudah dilakukan juga oleh salah satu APM di Indonesia, kendaraan bermotor listrik yang multifunction untuk kepentingan pertanian dan juga untuk mendukung kegiatan ekonomi sebagaimana kondisi yang ada di Indonesia. Berdasarkan penetapan tersebut, untuk program pengadaan bus listrik di Transjakarta, per tipe bus per tahun sebagai berikut. Jadi sudah ada rencana dari Transjakarta di tahun 2021, nanti single bus yang kemudian akan menggunakan listrik ada 70, kemudian yang low entry sekitar 30, dan tahun 2020 sampai dengan tahun 2030, itu akan digunakan yang single bus sekitar 153, yang low entry sebanyak 69, yang bus sedang sebanyak 239, dan berikutnya bus kecil sebanyak 284. Direncanakan untuk menggunakan bus listrik pada 11 kawasan strategis pariwisata nasional mulai tahun 2025. Jadi kami sebagaimana rapat-rapat yang selalu dilakukan, yang dipimpin oleh Kemenko Maritim, kami akan merencanakan sampai dengan tahun 2025, beberapa kawasan pariwisata kita akan gunakan bus listrik. Dengan Peraturan Menteri Nomor 65 Tahun 2020, pemerintah mendorong konversi kendaraan bermotor roda 2 dengan motor bakar menjadi kendaraan listrik berbasis baterai, guna mengakselerasi pemanfaatan kendaraan bermotor listrik berbasis baterai. Perlu menjadi perhatian bahwa setiap kendaraan konversi yang beroperasi di jalan tetap wajib memenuhi persyaratan teknis dan layak jalan. Dan untuk mewujudkan bahwa dukungan Kementerian Perhubungan menyangkut masalah uji tipe untuk konversi ini, kami mengusulkan kepada Kementerian Keuangan menyangkut masalah pembiayaan uji tipe untuk konversi sepeda motor listrik dari 4,5 juta menjadi sekitar Rp500.000, mudah-mudahan akan bisa diizinkan oleh Kementerian Keuangan. Sampai saat ini ada 3 bengkel konversi sepeda motor bersertifikat yang dikeluarkan oleh Kementerian Perhubungan, yaitu PT Braja Elektrik Motor, Bengkel Litbang Kementerian SDM, dan juga Eldes Garage. Sedang disusun regulasi untuk konversi kendaraan bermotor roda 4 dan lebih dari kendaraan bermotor bakar menjadi kendaraan listrik. Dan Damri di sini sudah melakukan riset and development, mudah-mudahan nantinya juga akan bisa, nanti kita akan membangun regulasi bersama-sama dengan pihak yang terkait, terutama dari APM, dan juga dari bengkel-bengkel yang saat ini sedang melakukan riset menyangkut masalah bus digunakan nanti konversi dari mesin bakar ke mesin listrik. Berikutnya Bapak-Ibu sekalian, saat sekarang ini kami sedang sangat intens sekali komunikasi menyangkut masalah penggunaan baterai swap untuk sepeda motor yang diikuti dengan standarisasi ukuran dan kapasitas baterai. Dan kami sudah ketemu dengan beberapa pihak yang terkait untuk kiranya nantinya ke depan dimensi baterai yang digunakan oleh beberapa merek sepeda motor kita harapkan mempunyai ukuran yang sama, sehingga nantinya ada kemudahan bagi masyarakat tidak harus ngecas di rumah, tapi kemudian bisa melakukan swab di beberapa perusahaan atau kemudian toko-toko retail yang ada, yaitu Alfamart atau Indomaret, sehingga masyarakat bisa langsung mengganti baterai yang habis di beberapa retail yang ada. Penggunaan baterai swab membantu dalam hal waktu charging. Jarak tempuh serta mengurangi nilai jual beli sepeda motor dikarenakan baterai sewa nantinya akan disiapkan di beberapa minimarket yang ada. Jadi nanti pada tahapan berikutnya, kami sedang menjajaki dengan beberapa APM, penjualan kendaraan bermotor atau sepeda motor listrik ini adalah hanya menjual sepeda motornya, tidak termasuk dengan baterainya. Karena baterai yang cukup mahal dan kita harapkan nanti baterainya adalah sewa di beberapa retail yang ada. Kemudian perusahaan produsen kendaraan listrik sampai dengan bulan Juli 2021, saat sekarang ini ada mobil penumpang yang bukan sedan, sudah ada 14 perusahaan, mobil bus ada 7 perusahaan, sepeda motor paling banyak ini ada sekitar 28 perusahaan. Dengan total adalah 49 perusahaan yang sekarang sudah ada di Indonesia. Data jumlah kendaraan listrik sampai dengan awal bulan Agustus 2021 yang sudah melakukan SUT dan sudah kami keluarkan SUT-nya, diantaranya yang sudah membuat SUT adalah mobil penumpang ada 44, kendaraan roda 3 ada 8, sepeda motor listrik ada 51, mobil bus ada sekitar 8, mobil barang 1, landasan bus ada 4, dan juga landasan mobil barang 1. Totalnya sudah kami lakukan uji tipe ada sekitar 117. Dan kemudian yang sudah didaftarkan dan sudah digunakan oleh masyarakat dengan ditunjukkan dengan dikeluarkan SUT dari Kementerian Perhubungan untuk mobil penumpang roda 4 sebanyak 1.478, kendaraan roda 3 ada 188, dan sepeda motor listrik ada sekitar 7.526. Mobil bus ada sekitar 11, mobil barang 1. Totalnya untuk SUT yang sudah kita keluarkan dan tentunya sudah didaftarkan juga di kantor Samsat Kepolisian dengan Dispenda sebanyak 9.204 kendaraan. Penggunaan bus listrik didahulukan untuk program kegiatan nasional dan juga internasional. Beberapa kegiatan yang akan menggunakan bus listrik sebagai alat transportasi, yaitu nantinya ada di Mandalika untuk G20 dan juga untuk KTT ASEAN. Dalam kesempatan yang berbahagia ini, saya menyampaikan apresiasi dan ucapan terima kasih kepada The World Bank atas penyelenggaraan workshop ini. Kegiatan ini sangat bermanfaat dan dapat memberikan pengetahuan tentang teknologi pada bus listrik serta infrastruktur pengisian daya untuk bus listrik. Para peserta sekalian yang kami hormati dan kami banggakan, saya kira untuk mendukung percepatan Perpres 55 ini, memang perlu kerjasama, perlu kolaborasi semua pihak, baik pemerintah maupun sektor swasta, terutama APM, penyedia kendaraan listrik, untuk sama-sama kita mengedukasi kepada masyarakat. Untungnya kita akan menggunakan atau percepatan penggunaan kendaraan dengan listrik ini adalah diantaranya untuk mengurangi polusi udara yang sekarang semakin kotor di negara kita, dan berikutnya juga kita akan meningkatkan kegiatan ekonomi yang lebih baik untuk kepentingan Indonesia. Jadi aspek edukasi kepada masyarakat untuk merubah mindset dari kendaraan motor-motor bakar kepada motor listrik, ini adalah tugas bersama. Saya kira kalau kita saling bergandengan tangan, apalagi kemarin untuk yang kendaraan konversi sudah berhasil kita juga membuat, dan kami sudah sepakat dengan Kementerian SDM untuk bisa juga mendidik UMKM untuk bisa dilatih dalam rangka membuat dan juga melayani atau kemudian mengoperasikan bengkel konversi listrik. Saya kira kalau semakin banyak bengkel konversi ini akan didirikan oleh UMKM, maka akan semakin cepat juga masyarakat akan beralih dari kendaraan sepeda motor bakar kepada sepeda motor listrik. Para peserta sekalian, saya kira itu saja yang bisa kami sampaikan. Dirgahayu Indonesia, Indonesia tangguh, Indonesia tumbuh. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Bapak Budi Setiadi. So, ladies and gentlemen, next we will have Benedict A. Bergen as the Practice Manager Transport East Asia and Pacific, the World Bank, to deliver an opening remark. To Benedict, the floor is yours.
Yeah, thank you very much, Vanya, for the introduction, and thank you, Honorable Budi Setiadi. I hope I pronounce the name correctly. Thank you on behalf of the World Bank, and thank to you and the government of Indonesia, all representatives from the various different kind of ministries. It's good to hear this, Papanas, Ministry of Finance, and so on. All line ministries are there. Also, good to hear that participation from Greater Bandung, and other NGOs as well, and interested stakeholders to this workshop. It's a great opportunity to discuss further the technology selection and business models for e-bus deployment. So it's a very important area of discussion, and I'm very happy that the bank can support this initiative. Let me go through a few trends, developments, challenges, and opportunities, and explain a little bit what the World Bank is doing here. You may ask that question, as why is the World Bank here involved? So we'll leave that also to Rahul Gupta to explain that later. But let me go through a few areas that needs to be highlighted here. Don't want to take too much time because I would like to leave the floor and time to the discussion. And that's way more important than have lengthy kind of presentations from representatives. So bear with me. I will go through a few areas. So the urban transport sectoral context in Indonesia is rather complex and is moving rapidly to a certain direction that needs to be addressed. For instance, the rapid urbanization of Indonesia and the insufficient provision of public transport services have led to a situation of an unsustainable kind of growth in car and motorcycle ownership, and with high levels of urban congestion and air pollution, as earlier mentioned very clearly. So the rapid urbanization, for instance, more than half of the Indonesian population lives in cities. By 2045, nearly 3/4 will. It's amazing. And in 2016, Indonesia had 14 cities with a population greater than 1 million and 12 cities with a population between 500 and 1 million. Again, mentioned insufficient provision of public transport. The cities that have invested most in mass transit, Jakarta and Bandung, achieve a public transport modal share of around 15 to 20%. By contrast, large and rapidly growing cities in China generally attract 20 to 30% modal share for public transport, while other Asian cities with well-developed networks such as Seoul, Singapore, Tokyo, Hong Kong, Mumbai, and Kolkata achieve modal shares for public transport of more than 50%. Then there is the unsustainable growth in car and motorcycle ownership. Just in the period between 2007 and 2017, in that 10 years, car ownership increased at 8.5% per year, and motorcycle ownership at 10.5% per year. The high level of urban congestion, just a recent study, 2019, a World Bank study found that that they are slow, not only in peak periods, but throughout the day. And traffic is moving very slowly, and especially for public transport vehicles with a daily average of between 23 and 28 kilometers per hour. And the second point was out of that study that the estimated economic losses from traffic congestion in major cities is leading to a loss of $5.6 billion. Another aspect is the high level of air pollution. According to the World Air Quality Monitoring Network, 6 of the 10 most polluted cities in Southeast Asia are located in Indonesia. In 2019, Jakarta was the most polluted capital city in the region in terms of PM 2.5. These numbers are well above the annual mean exposure threshold of 10 UG per meter defined by the World Health Organization. So it's that on-road transport is a major source of ambient air pollution in Indonesia. It contributes to around 12% of the total CO2 emissions and almost 90% of the CO2 emissions and the hydrocarbon, the NOx and the sulfur oxides, the PM and the ozone. So a lot of things are coming here together in terms of the air pollution. And not only that, there's an estimated 7,000 deaths occurred in 2015 due to exposure to the ambient PM 2.5. So there is a clear link between the air pollution and deaths caused by that. So then we get to the second kind of point. The Indonesia's vehicle emission standards, including for buses, still allow significant emissions of harmful pollutants. The country, Indonesia, plans to toughen the emission standards for its vehicles, including its bus fleet, but it might run short, so perhaps more is needed. Currently in Indonesia, diesel buses are required to meet tailpipe emission standards that are outdated in Europe and other developed economies for more than 30 years, the Euro 2 standards. Indonesia plans to transition to a cleaner emission standard, the Euro 4, for its buses by April 2022. In the region, in the East Asia region, Vietnam is scheduled to adopt Euro 5 standard in 2022, and Thailand is considering to adopt Euro 6 standard in 2023. Although Indonesia is catching up with Europe and neighboring countries, the Euro 4 diesel emission standard will still allow, regrettably, significant emissions of harmful pollutants. Let me go to Indonesia's climate change commitments in this regard. Indonesia's first national determined contributions, the NDC, for the Paris Agreement, pledges to achieve a unilateral greenhouse GHG emissions reduction of 29% and conditional, with sufficient international support, a reduction target of up to 41% against the business as usual scenario by 2030. To achieve its Paris Agreement, Indonesia reported 15 transportation mitigation actions that cover land, rail, marine, and air transport in its second biennial update report. Actions related to land transport include technical efficiency development of transit system through bus rapid PRT projects, application of traffic management technology in national main roads, implementation of traffic impact management on national main roads, and modernization of public transport. In 2021, I think it was mentioned earlier, in April 2021, the Ministry of Environment and Forestry announced a long-term strategy on low carbon and climate resilience 2050, which has the target to achieve of 2 million of electric cars and 13 million of electric motorbikes in 2030. So that's encouraging. So the global e-mobility adaptation in mass transit and trend forecast. So let me try to give you a bit of an overview here on the global scale. The main metropolitan areas around the globe are increasingly considering the adoption of e-mobility to renew and expand its bus fleets to contribute to combat urban air pollution and climate change impacts. A number of cities, especially in China, Europe, India, and America, have announced bold bus electrification goals and programs to overcome the prevailing barriers and accelerate e-bus uptake. As e-mobility technologies become more affordable and replicable, a wide range of countries are showing their interest for their adoption. So we can give you later on some examples around the world, and Bloomberg Annual Electric Vehicle Outlook is giving those examples in China, in Europe, Latin America, and so on. So let me go to the e-mobility status in Indonesia. I think we can all agree that e-mobility in Indonesia is still in its nascent stage. The government of Indonesia is strongly supporting the industry development with policy issuance and subsidies. E-mobility adoption will contribute to reverse air quality worsening trends and achieve Paris Agreement goals. So that is very, very good. In 2019, the government of Jakarta expressed its commitment to only operate e-buses in the city. The Transjakarta conducted an e-bus pre-trial in 2019 and 2020. So from 2021 to 2022, the Transjakarta will run a pilot with 100 e-buses. Bandung and Surabaya are preparing e-bus pilots as well. E-taxis and innovative e-motorcycle business modes have emerged in the past year as a response to the set of policies favorable to e-mobility and as new business opportunities. Let me go to a final point I would like to make. Why is World Bank here, and what is the World Bank support? The World Bank is currently preparing the Indonesian Mass Transit Program support project. The acronym is IMTPSP, that's a long one. This project is to enhance urban mobility and accessibility on high priority corridors in the metropolitan areas of Medan and Bandung. In particular, the IMTPSP, the Indonesian Mass Transit Program supported project, will support the development of BRT corridors in Medan and Bandung, where diesel is still the default fuel. So with support from the Mobility and Logistics Trust Fund, the MOLO Trust Fund, and the Energy Sector Management Assistance Program, ESMAP, the World Bank is implementing a technical assignment titled E-Mobility Adoption Roadmap for the Indonesian Mass Transit Program. And that is meant to explore the potential to leapfrog to e-mobility technologies in the mentioned BRTs in those cities. One of the objectives of this technical assistance is to carry out capacity building and knowledge exchange options to raise awareness of the benefits of adopting e-mobility and mass transit systems. Following the workshop on e-mobility and mass transit, global case studies and Indonesian policy review that was held in June 2nd and 3rd in 2021, this second workshop is conducted to share global knowledge on the selection of the most adequate technology to deploy battery electric buses, BEBs, and charging infrastructure in metropolitan areas. And also to discuss potential business models to finance and operate these systems. The workshop will facilitate knowledge exchange with global experts on BEBs and charging infrastructure state-of-the-art technologies and selected cities, countries and regions that have adopted already innovative business models for BEBs deployment, including, as mentioned earlier, Chile, India, and Singapore. So to implement this technical assistance, the World Bank hired a consortium, a group of consultants led by ITDP, Institute of Transportation and Development Policy, and supported by the International Council on Clean Transportation, ICCT. So let me thank the host of this event, and especially thank the Indonesian government again for hosting this wonderful exchange and opportunity to discuss further. And also thank MOLO and ESMAP for financing this technical assistance. So back to you, Vanya, and wish you a lot of success and a very fruitful exchange. Back to you. Thank you very much.
Thank you very much, Benedict, for your insight. And after this, we will have Bapak Firdausi Manti as the Assistant Deputy for Maritime Industry and Transportation, Coordinating Ministry for Maritime and Investment Affairs, the Republic of Indonesia, to deliver a keynote speech. Mohon izin, Bapak Manti. Selamat pagi, Pak.
Baik, terima kasih. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Yang saya hormati, Bapak-bapak, Ibu, pejabat di lingkungan Kementerian Lembaga, Pemerintah, Daerah yang hadir atau terundang hari ini. Yang terhormat Bapak Dirjen Perhubungan Darat, Bapak Dirjen Ilmate Kementerian Perindustrian, teman-teman dari Kementerian Keuangan, kemudian dari Dirjen Ketenagalistrikan SDM, Direktur Transportasi Bappenas, Kementerian LHK, dari OJK, kemudian juga pemerintah Provinsi Sumatera Utara, Jawa Barat, serta para pimpinan perusahaan PLN, kemudian juga manufaktur bus, manufaktur charging station, masyarakat tenaga listrik Indonesia, masyarakat transportasi Indonesia, dan kedutaan besar Kerajaan Inggris, serta bapak-bapak, ibu-ibu dari World Bank, dari ITDP, dan ICCT, serta hadirin peserta lokakarya elektrifikasi sistem transportasi massal untuk mendukung percepatan kendaraan bermotor listrik berbasis baterai, teknologi dan model bisnis yang saya hormati. Terima kasih atas waktu yang diberikan kepada saya, Mbak Fania, Mbak Bella. Pertama-tama saya mengucapkan permohonan maaf dari Pak Deputi yang pada saat ini yang bersamaan ya, beliau tidak dapat hadir karena ada tugasan lain, sehingga beliau meminta saya untuk mewakili beliau. Terima kasih kepada ITDP, Asia Direktur, Bella, yang berinisiatif mengadakan acara ini dan mengundang saya memberikan untuk keynote speech. Baik, Bapak-Bapak, berbicara mengenai KBLBB akan berikutnya, kendaraan bermotor listrik berbasis baterai atau battery electric vehicle, tentunya terkait erat kaitannya dengan peta jalan ya, roadmap industri kendaraan bermotor listrik berbasis baterai itu sendiri. Pada saat ini, peta jalan industri untuk kendaraan bermotor listrik berbasis baterai, baik roda 2, roda 3, roda 4 atau lebih, telah disusun. Adapun peta jalan ini itu menggambarkan ya peta pengembangan industri kendaraan bermotor listrik berbasis baterai tersebut dalam jangka waktu kurang lebih 10 tahun ke depan sampai sekitar 2020 sampai 2030, yang mana tahapannya akan terdiri dari CKD, complete lockdown, kemudian dilanjutkan dengan completed lockdown, kemudian part by part. Tahapan ini tentu akan didorong dengan berbagai inisiatif di masa mendatang, sehingga pengembangan dari kendaraan bermotor listrik berbasis baterai ini akan sesuai dengan target yang ditetapkan. Karena tentunya sesuai dengan Perpres 55 tahun 2016, salah satu tujuan dari Perpres ini adalah untuk meningkatkan industri dalam negeri, industri kendaraannya, industri komponennya, ekosistemnya, terkait dengan kendaraan listrik berbasis baterai. Kami berharap melalui peta jalan ini akan semakin banyak industri kendaraan KBLBB yang dapat berinvestasi di dalam negeri dan meningkatkan pendalaman komponennya. Selain itu, melalui peta jalan ini diharapkan dapat terbentuk sinergi antara ekosistem antara industri hulu sampai dengan industri hilir dalam memenuhi kebutuhan dari tingkat komponen dalam negeri industri tersebut. Potensi Indonesia tentunya ada sebagai produsen kendaraan bermotor listrik berbasis baterai sangat besar. Saat ini pun kita juga menjadi produsen, salah satu produsen ya, di Asia Tenggara yang besar. Hal ini didukung juga oleh beberapa investor yang telah menanamkan stasinya untuk memproduksi kendaraan bermotor listrik berbasis baterai di Indonesia. Hyundai yang membangun basis kendaraan listrik di Indonesia, kemudian untuk baterai ada CATL, ada LG Chemical, kemudian ada QNB New Energy yang akan membangun industri bahan baku baterai. Kemudian juga saya sampaikan tadi, Indonesia merupakan memiliki jumlah pasar yang terbesar untuk kendaraan bermotor khususnya di ASEAN. Penjualan mobil Indonesia itu mencapai lebih dari 1 juta unit pada tahun 2019 dengan kapasitas produksi 1,8 juta unit dengan total investasi hingga tahun 2018 sebanyak 92,87 triliun rupiah. Selain potensi market dan potensi industri KBLBB dalam negeri, teknologi juga menjadi faktor kunci untuk pengembangan KBLBB itu sendiri dan ekosistemnya. Pengembangan teknologi untuk industri kendaraan listrik diharapkan dapat mendorong harga kendaraan listrik menjadi lebih kompetitif. Selain itu, pilihan-pilihan atau model berkendara termasuk sistem otomasi untuk kendaraan-kendaraan listrik ini juga diharapkan makin ditingkatkan sehingga dapat mendorong faktor keamanan keselamatan. Tentunya juga tadi yang paling penting adalah untuk kendaraan umum ya, yang saat di dalam workshop ini kita juga dorong memang untuk mulai transformasi kendaraan-kendaraan umum untuk digantikan ke depannya menjadi kendaraan listrik, tidak hanya bus-bus dalam kota dan lain, mungkin juga nanti semuanya ke depannya perkotaan, angkot-angkot kecil dan lain-lain juga kita berharap itu bisa ditransformasikan menjadi kendaraan listrik. Selain itu juga stasiun pengisian daya menjadi faktor yang penting untuk terus didorong untuk semakin meningkat jumlahnya. Selain itu teknologi pengisian daya dengan teknologi ramah lingkungan solar panel juga telah menjadi pilihan strategi bisnis dalam pengembangan infrastruktur charging station di masa yang akan datang. Kecepatan pengisian juga menjadi concern yang tidak kalah penting agar pengisian daya ini dapat dilakukan dalam waktu relatif singkat. Tentunya dengan perkembangan teknologi ya, kita berharap pastinya sih saya yakin hal-hal ini kedepannya akan tidak menjadi masalah karena teknologi itu cepat sehingga tadi faktor-faktor pengisian waktu pengisian itu bisa dipercepat, ukuran baterai bisa diperkecil, lebih efisien, harga juga lebih bersaing sehingga kedepannya memang sudah tentu di seluruh dunia pun akan menggunakan teknologi menggunakan kendaraan bermotor listrik. Saat ini juga pemerintah Indonesia sedang menyusun gerakan strategi energi nasional sebagai materi masukan untuk penyempurnaan rencana umum energi nasional atau UEM. Pemerintah terus mendorong penggunaan energi dalam negeri yang ramah lingkungan di dalam termasuk di dalamnya adalah energi baru terbarukan. Total potensi energi baru terbarukan saat ini ada sekitar 417 gigawatt, di mana pemanfaatannya masih kecil, baru sekitar 10,5 kali ya gigawatt atau sekitar 2,5% dari potensi yang ada. Sehingga sudah saatnya Indonesia kita ingin beralih ke energi baru terbarukan ini agar tidak tergantung kepada energi fosil yang jumlahnya juga sangat terbatas dan akan habis pada suatu saat nanti. Dari potensi 417 gigawatt ini, potensi energi surya menempati urutan teratas dengan potensi sekitar 207 gigawatt atau sekitar 50% dari total potensi EBT yang ada. Tentu selain itu masih ada ya beberapa potensi EBT yang lain seperti hidro yang ada potensi ada 75 gigawatt, energi bayu sebanyak 60,6 gigawatt, bioenergi sebanyak 32 gigawatt, panas bumi sebanyak 24 gigawatt, kemudian juga samudra ya, teknologi gelombang laut, energi panas laut dan arus laut sekitar hampir 18 gigawatt. Jadi yang pasti Bapak Ibu dari yang tadi juga saya sampaikan juga tadi yang sudah disampaikan oleh Pak Dirjen Perhubungan Darat bahwa pemerintah tentunya sangat punya komitmen yang kuat ya untuk memenuhi bauran energi yang khususnya EBT tadi dalam rangka mendorong semuanya ramah lingkungan ya, kendaraannya ramah lingkungan, energi daya energi juga ramah lingkungan. Kemudian salah satunya adalah solusinya adalah KBLB tadi yang sangat konkret untuk mendorong bauran energi ini. Sehingga bauran energi, selain bauran energi, target pengurangan konsumsi BBM dan polusi udara juga dipenuhi. Melalui transformasi penggunaan KBLBB untuk kendaraan dinas operasional pemerintah termasuk bus-bus jemputan yang tadi disebutkan oleh Pak Dirjen, ini juga melakukan langkah-langkah konkret dari pemerintah pusat untuk mendorong percepatan KBLBB ini. Selain itu tadi sektor angkutan umum ya, bus-bus angkutan umum juga menjadi faktor yang sangat penting yang kita dorong, pemerintah mendorong untuk dilaksanakan. Akhir kata saya juga mengapresiasi, mengucapkan selamat atas dilaksanakannya lokakarya elektrifikasi sistem transportasi massal untuk mendukung percepatan KBLBB ini. Semoga acara hari ini dapat mendorong percepatan KBLBB dan ekosistem di masa mendatang dan kita dapat mendiskusikan ya segala hal terkait hal ini dengan baik. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh. Sorry Mbak Fania, makasih.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih banyak Pak Manti. We already have Francisco Posada as the senior researcher at the International Council on Clean Transportation, who will give an opening session. Please welcome Francisco.
Thank you, Vania. Honorable representatives of the government of Indonesia, line ministries, and provincial government, respected colleagues. It is my pleasure to open the presentations to this workshop on electric bus deployment technology, selection, and business models. The government of Indonesia is promoting a sustainable and clean transport sector with the adoption of Presidential Decree 55 of 2019 on the acceleration of battery electric vehicle programs for road transport in that year. This electromobility program is expected to reduce greenhouse gas emissions, reduce the country's reliance on fossil fuels, and enables Indonesia to maximize the use of its abundant mineral reserves for battery production. Public transit electrification is one of the priorities of the government of Indonesia to accelerate the electromobility adoption in the country. Cities around the world face the same challenges that Indonesian cities encounter today to scale up mass transit system electrification projects. Market readiness of these new technologies, charging infrastructure requirements, design and implementation, planning of this new technology, and higher upfront costs are some of the key questions that need to be addressed. The design and implementation strategy for public transport electrification, including sound business models, are crucial to ensure the success of battery electric buses deployments in the cities. The objective of these second workshops on mass transit electromobility for Indonesia is to provide an overview of considerations for battery electric buses, as well as charging infrastructure technology, and to discuss potential business models to finance and operate these technologies. The workshop is structured in two modules. During the first module, we invited experts to share their key considerations on battery electric bus technology. This will be presented by P. Manifold. Charging infrastructure, which will be presented by McKinsey Consultants, and technical planning for electric bus adoption in cities. Two cases will be presented to explore the steps taken to plan for electric bus adoptions, first in Jakarta, Indonesia, by the ITDP team, and in Bangalore, India, by my colleagues from ICCT. During the second module, the experts will introduce innovative business models and financing mechanisms for electric bus deployments, first at the global level by C40, and after that under 3 different countries. We selected Chile, India, and Singapore as they provide examples of business models that are relevant for the Indonesian context today. This will be presented by Centro Mario Molina, Chile, by UITP from India, and from the Land Transport Authority of Singapore. They will also share the business model evolution from the traditional bus service towards a service that is based on battery electric buses. At the end of each module, we will spare 20 minutes for questions and answers. We expect that this exchange of ideas and experiences by institutions and cities that have advanced from the pilot stage to scaling up electric bus deployments can serve as a model, as inspiration for Indonesian cities in their pathway towards electric bus deployments in the country. Thank you very much. And Vania, back to you.
Thank you very much, Francisco, to open our session for today. So I'm very honored here and also excited to introduce you to our distinguished speakers who are already joining us into this program. So for the first panelist, here we have Rahul Bhaktia, who will bring the topic on electric bus technology selection. And he has already more than 20 years of research and consulting experience with a focus on clean energy and mobility sectors, including electric vehicle. So Rahul is Managing Director and co-founder of P Manifold, a strategic research and consulting company. He has led various clean mobility and sustainable programs funded by international agencies like the World Bank, United Nations, or the Asian Development Bank. He has dual master in mechanical and electrical engineering from University of Michigan, and also Bachelor of Engineering in Mechanical from National Institute of Technology of Nagpur. So please welcome Rahul Bhaktia.
Thank you very much, Vania. Very good morning, everyone. Pleasure to be speaking on this very credible platform. And thanks to all the Indonesian stakeholders for really making time and organizing this knowledge exchange. Next slide, please. I'll be focusing, possibly giving a leeway into this entire workshop on what existing technologies of buses, batteries are existing, for what reasons, and what trends to expect going forward. I will also connect to the battery recycling and reuse and creating a circular economy. Overall, we'll focus on e-buses primarily. So here I have brought about like what are the technologies upgrades that has happened broadly in the bus segment globally. We started with ICV segments, and then we had hybrids coming in. And hybrids, there are two kinds of hybrids that I'm talking. First, the plug-in hybrid electric vehicle, which is a parallel hybrid. By the use of word parallel, I mean like here the engine is supplemented by motor and battery, and we kind of drive the motor use only for the areas where engine is non-efficient. So in that way, we are driving higher efficiency through a mix of battery and motor in addition to the electric source. So in plug-in hybrids, as the name suggests, they are parallel hybrids. We have both. The shaft and wheel is connected to the engine as well as to the motor, and depending upon the area, so like for short and stop events, parking, congestion, driving, it will be the motor that will be driving the shaft, so that drives higher efficiency. In the second case, which is extended range electric vehicle, this is a parallel hybrid, this is a series hybrid. So by that, what do I mean? Here we kind of go with smaller engine and higher battery capacity, and engine is used kind as a genset. So engine is used only for charging of the battery, though it also allows parallel charging through external electric source, but engine is used only for charging the battery, and the entire wheel shaft is driven by motor and the battery combination. So engine will not directly drive the wheel. Engine will only charge the battery, and it is the battery and motor that will drive the vehicle. And this is a higher integration towards pure electric option. Then we are having the pure electric options. I am glad that Indonesia is very strongly consider the route of pure electric for its e-buses and other options. And I think it makes a lot of sense with the given price economics and performance from the pure electrics. And many of the countries have now started piloting hydrogen options. And that is primarily in coming years will be the fuel cell driven options. So these are the technologies that are prevalent for decarbonizing overall electrification, specifically focusing on the buses. Want to highlight one thing around hydrogen, which is less understood. Hydrogen, when we are talking of hydrogen or fuel cell technology, it will still use batteries, right? So we are not getting out of the batteries, though the size of the batteries will kind of get reduced. So in hydrogen, the configuration is like you have a hydrogen tank, you will have a fuel cell, which will convert hydrogen into electricity. And by way of conversion and the best efficiencies in fuel cell are still 50%. Over time, it may increase, but that is the current technology maturity of hydrogen to electric conversions on board. And then when you have the fuel cell, it's primarily the energy supplier to the wheel. It's not really the power supply, right? So by power is that spontaneous high load that you need to apply that need not be coming from the fuel cell. If you want to drive the fuel cell in power applications, then you would have to size it higher and the cost of fuel cell will increase. So the way it is kind of being optimized is to use a smaller size fuel cell for more energy applications and then drive the power applications through a separate battery arrangement. And here the entire load is still driven through the motors. So hence in the diagram I have shown fuel cell. If you look into the efficiencies in terms of the energy to kilowatt hour per kilometer efficiency, then battery electric vehicle stands fairly high. I'm showing it higher than fuel cell because fuel cell you have the onboard conversion of hydrogen to electric and that efficiency is low. Whereas in electric, I am assuming that electricity is coming from a source outside the vehicle. But of course, we have to be considerate about the energy that the electrical energy that gets feed for all the fuel cell hybrids and even the pure electric options. The cleaner energy will drive lesser of the pollution issues, which I think is primary concern for Indonesia to shift to electric. In terms of the infrastructure, I think the previous speakers have really brought the right need of right charging infrastructure to be set up. Next, please. So in previous slides, we talked about e-bus technologies. As I said, like the prevalent technologies globally are now pure electric options, and that requires batteries. And lithium-ion batteries have become one of the major type to be used in electric. And with more and more maturity, the stability and price economics are turning more favorable. Again, there are different drivers, different parameters, which defines like what battery will suit to what best applications. In bus application, which is focus of this topic, primarily 3 configurations are most getting used globally. The second option, lithium phosphate. The third one is the nickel manganese cobalt, which normally called as NMC. And third is lithium titanate oxide, LTO. So these are the 3 most, I would say, prevalent chemistries that are getting used for e-buses. Now, how do you choose one chemistry over the other? Can we do this chemistry selection in isolation to the applications or to the region of operation? The answer is no. We really have to be conscious of the applications, which includes like what distances we are traveling, the traffic conditions, the on and off stop events, the temperature conditions in which it will be exposed to, the charging strategy, the charging power, the frequency of charging. So all these are different parameters which really kind of will lead to a right optimal selections of the batteries. Just to give you an example, like if you take lithium titanate oxide LTO, it has very high, in fact, highest charging rate, C rate. So that means that you can charge these batteries very fast, like in 10 or 15 minutes, you can charge it full time. But then the trade-off is that its energy density is poor. You will have to carry a huge weight of LTO for providing you that charging efficiency or charging power, and that higher weight of LTO will also come at a cost of reducing your vehicle mileage, right? So these are the trade-offs that you have to trade. NMC has picked up in terms of global trends for both light as well as high load applications. Primarily, its energy density that is getting improved with more and more chemistries and variants coming in. Its C rates are reasonable. for the kind of charging that supports the overall battery life. Life cycle of NMC is definitely lower than that of LTO, but then the price point that it comes, so it's again a trade-off that is kind of has to be studied application to application while you select the battery chemistries. Next, please. Here I want to kind of bring about like how globally the different e-bus technologies have evolved, how some of the countries, so like if you see Europe and US, they have gone through pretty much all the technology options, and all the technologies are coexisting, including hybrids, both parallel series, pure electric, as well as the hydrogen. If you
Excuse
look
me,
into,
Rahul?
yes, Vanya.
Excuse me, you have 5 minutes left, Rahul. Thank you very much.
Sure, sure. Thank you very much, Vanya. And if you look into Scandinavia countries, Sweden, Norway, they are jumping to the hydrogen economy because of abilities to set up the hydrogen infrastructure. China, if you will see, similar to India, have skipped the entire hybrid route and jumped directly to the pure electric and hydrogen option. China is more supported by its strategy to become a manufacturing hub and leader for all the batteries and hydrogens. Hydrogen, Japan, you see that it's primarily dominated by the big major automotives like Toyota, Honda, and they have stick to the uh, uh, hybrid routes and now jumping directly into the hydrogen route. So combustion engine driven either by hydrogen is still remains a very important part of their legacy. Latin America is going on more biofuel routes, so they continue to use the ICV vehicle engines and using more and more biofuels, even to the extent of 90% of ethanol mix. Next, please, Manisha. Next. Here I have kind of provided key steps that goes into e-bus technology selection and fleet planning. The most important of this is understanding the duty cycle of the e-bus, which I believe is at the heart of conducting any form of technical feasibility for e-buses. Many parameters which drives how much energy the e-bus will consume for the specific route that you want to operate. And once you understand those energy signatures in the application you want to drive e-buses, then you define the charging strategy in terms of like, do you want to go with full depot or mix of depot or opportunity charging, depending on the availability of space and electrical connections. And then you kind of iteratively design like what is the right battery chemistry and size of the battery that will match your applications. And once you have done that, then you freeze your charging specifications, you design your operations and fleet planning, and then you conduct your TCO or financial analysis. Then you verify that you are able to meet all the operational SLAs committed, and then you kind of go into the loop for further optimizing the design parameters. Next, please. This is a very short case study based out of India, comparing the IC buses and e-buses, going through the same steps that I just highlighted. This is a 9-meter bus with air conditioner, an electric option for the kind of demand. It is using 320 kilowatt-hour battery packs. Next, please. The left-hand side is what is the detail kind of goes on in terms of understanding what route the e-bus is running, what will be its duty cycles, what energy signatures, what battery and motor designs, how do you schedule your chargers. On the right side, I'm showcasing very top results of TCO analysis once after doing the entire techno-commercial analysis. So here you see that without subsidy, the electric buses still flares a little higher than ICE bus cost. And you will see that the fuel cost, the orange in color, in electricity is almost lower than 1/3 of the diesel cost. Yeah, but you also see that the battery capitalization cost is quite higher in case of electric, which is actually resulting into the higher TCO. And hence, when you are looking for with subsidy options, with subsidies targeted on the batteries, you are able to have with subsidy TCO lower than e-bus option. So this also gives a leeway into right business models for e-buses, which I hope my colleagues will be talking in next sessions. Next, please.
Rahul, could you please jump into the conclusion because we are running out of time. Thank you.
Sure, sure. Thank you very much. I will skip this slide. These are all factors which drives the range and considerations for EVs. This is my last slide because we are talking of pure electric, which will, the energy source is the battery. So there will be a heavy recycling of the battery that is happening. Why recycling or reuse is important? One, for definitely environmental reasons, but second, very most important factor from economic side is the value that the bus operator needs to plan. One, it has to figure out that what is the salvage value of this battery when it goes out, and how much new capex that he has to plan when he does the replacement of the batteries. So from that angle, recycling and reuse becomes very important. After finishing the first life in the e-buses, which is usually kind of reaching to a energy capacity of some 70%, the battery is ready to go into the second life stationary applications. So in case of bus depot, what can be those stationary applications? One, you can replace your existing diesel set if you are providing any for providing power backup with the stationary use of the batteries, and that allows you to integrate both grid as well as solar power. And second, if there are fluctuation of powers in developing countries, this is important. The stationary applications of batteries can give you kind of good power regulations. And this you can do it in the depot itself. Or of course, you can go directly to the salvage value and the aggregator will take up this repurposing applications. And after further fading another few years into that application, then it goes into the end of second life. And that's where it needs to go into the repurpose, recycling, and back to the circular economy of extracting those precious elements, metals of the battery and recirculating into the new battery applications. The key message for country is to really kind of start planning for repurpose and recycle of the batteries. Two main important considerations. One, how do you drive a right collection mechanisms from bus depots to the back to the OEMs and to the aggregators? And second is what technologies the country has to really start making plan for driving recyclings. And there are multiple considerations. I will take a hold there and take more questions in my session. Thank you.
Thank you very much, Rahul, for your presentation. So, ladies and gentlemen, we talk about available technology for BEVs, and now we're going to look at the charging infrastructure. And I would like to introduce our next speakers. In the second presentation, we will have two speakers. We have Rahul Gupta. He is a senior expert with McKinsey Global Energy and Materials Practice. His experience is focused on sustainability topics like EVs, green business building, and decarbonization for Asia Pacific. And on EV, he has worked across multiple Asian countries, providing consulting support to a broad set of clients to help them with their go-to-market entry strategy, commercial due diligence, and also operationalization. Rahul has a bachelor degree in chemical engineering from Harcourt's Butler Technical University, India, and an MBA from Shailesh Jayamantha School of Management, Indian Institute of Technology, Bombay. And also for the next speakers, also we have Vishal Divergent. He is an expert with McKinsey Global Energy and Materials Practice, and his focus is on energy transition within EV space for the Associate of Southeast Asian Nations, and has provided consulting support to broad set of clients to help to maneuver to enter the EV space, and his expertise is focused on 2- and 4-wheelers and related to charging infrastructure planning. Vishal has a bachelor degree in civil engineering from Indian Institute of Technology of Kagapur, with a specific focus on transportation and environmental engineering. So, to Rahul and also Vishal, we have 15 minutes for your presentation. The floor is yours.
Thank you, Vanya, and thank you everyone for having us here to share our perspective on the charging infrastructure. I think if you move to the next slide, I'll just basically share high-level key messages. So I think, as you've also heard in the morning, we do see a significant penetration of EVs, reaching up to about 2.7 million units globally. And this is driven by the TCO economics, as Rahul has shared. I think a lot of regulatory supports which countries are driving, and setting up an availability of charging infrastructures and availability of vehicles. Vishal would cover in detail about the 3 different charging infrastructure, which is the depot only or opportunity charging and charging using overhead wires. And we would then also share with you how we would, how countries could think about setting up a charging strategy, which is looking at simultaneous evaluation of the route, archetype, the vehicle specification, charging speed, and charging business model. And lastly, we'll end up with the business model archetype, which I assume we would go in more detail in the second session. If you go to the next slide, I think just a quick recap from the analysis which McKinsey do as part of a global energy perspective, wherein we forecast the growth of EVs dependent upon certain economic drivers like the TCO parity, what kind of regulatory supports are given, what are the charging infrastructure available, and the availability of OEM vehicles. We do expect a significant growth, almost reaching about 10 million vehicles by 2050. Most of this is again coming in from China and then OECD Europe. Moving to the next page, I think similar to what a colleague before has shared, one of the key drivers has been total cost of ownership. So this analysis was done for EU, where we do see that total cost of ownership is already reaching parities in EU, and hence you see a significant uptake. If you go to the next slide, we see a lot of regulatory push. I think we covered in the morning about Indonesia, where they're targeting 10K or 100% of e-bus running on Jakarta roads. But we are basically seeing a lot of similar incentives being given or plans being laid out by the local governments in terms of electrifying the bus system. Yeah, if we go to the next page, yeah.
All right. Here we thank you so much, Rahul. And assalamu alaikum. Really nice to meet everybody. We talked about OEM models. We talked about the different parameters and economics regulation. Right now, let's try to get into the grasp of charging. Now, when we talk about e-bus charging infrastructure, you more or less have 2 big opportunities, right? Which are depot charging and opportunity charging. Hybrid is more like a trolley legacy system, which is dependent on a legacy infrastructure, so not very relevant from an Indonesian point of view. Right? So during the course of this presentation, we'll try to make it real for the objective of this conference, which is in terms of setting up e-bus charging infrastructure. Now, as you can see on the slide, is each of the opportunities, each of the charging options that you select, they have different power requirements. Right? They have different power requirements. When we look at depot charging, it's relatively overnight slow charging, right? And we see this, I'm talking about here, right? And we see this becoming more relevant in geographies or in routes with a smaller distance, for which you don't need to charge in the course of the duration, right? So, and on the other side, you have opportunity charging, right? Here, the angle is that just charging at your depot is not sufficient. Hence, as a result, you need to charge in addition to the depot in the route as the vehicle is moving forward, right? So what does that mean? That means that you need to charge during operation. As you need to charge during operation, you need to charge faster. As you need to charge faster, you need higher power output, right? So if you can see the difference in power output between depot charging and and opportunity charging, you see a difference there. Yeah. Now within opportunity charging, right? So I think in Indonesia at some level both are applicable, but what we see is that the industry is moving more and more towards opportunity charging because the distance per day per vehicle is increasing. Yeah. Now within opportunity charging, if we look at different options that are there are certain options which are pretty well defined, which are the standard plugs. Right. So these are the standard plugs that we see, which is, depending on the model that you have, which is either the Chinese standard or the European standard, or, or CHAdeMO, etc., which is the standard plugs that you see. Right. Now, these are more often than not giving you a charging of about 10 to 45 minutes. Right. Important to mention, just because you have opportunity charging, that doesn't mean that you do not do an overnight slow charging. Right? Or the opportunity charging is over and above an overnight slow charging that you would do in the depot anyway, right? Because slow charging has its benefits. It prolongs the battery life, right? It prolongs the battery life of your entire vehicle, right? The BMS has less pressure on it. So there are certain aspects to that. The opportunity charging is more on the need of the day, as how do you cater for the additional charging requirement driven by the high utilization of the vehicle in terms of distance. Yeah. So that's where it comes in. Now, the most common method of opportunity charging that we see picking up is the pantograph. And I will walk you through that in detail. What does the pantograph mean? How does it look? Right. But also want to mention here that there are ongoing pilots. There are ongoing pilots on induction charging. So just want to call that out in terms of tech, right? Futuristic, we do see certain areas where there are pilots being done on induction charging. What is induction charging? You have sensors being laid out on the road, right? And that kind of interacts with the underside of your vehicle, and your underside of the vehicle has your battery platform, which it can charge directly. But currently we don't see it being very economical yet. It is still in the form of pilots. Right. So that's how we see the global framework of what are the different options you have when we talk about charging. Now, why don't we go to the next slide and talk a bit detail about the pantograph option. Right. Now, pantograph option, very straightforward. You see two options. Right? We have tried to simplify it with a figure. Right. If you see here, so there is one option in which you have an apparatus. Right. You have the apparatus which is mounted on the roof of your bus. Okay. Roof of your bus, and it kind of extends, connects to a cord, and you charge. And the other side of it, which is on the right hand side, which is the other way around, right? So your roof of your bus already has the socket, right? The pantograph is already installed, and it kind of comes down and interacts with the bus and charges. Now, what is the need of each of these options, and what are the pros and cons as we see it, right? Number one, independent of the option you select, this is a very good option when we talk about fast charging, right? In fast charging, particularly given the size of the batteries that you have, right? In an e-bus, which is much bigger as compared to E4W or a passenger vehicle. Now, within this, what we see is there are two parts to it. There is number one is the process itself, which I explained, right? If you look at the pantograph on the right hand side, what is required is that the connection is via a data network. It is via a Wi-Fi network, which is required for the communication to take place between the vehicle and the roof mount, which is probably not very much required when we talk about CCS. There are certain pros and cons for each. Let's look at that in a bit, right? The pros and cons of a roof mounted or a pantograph up roof mounted on the left hand side is as follows. Number one, if your pantograph fails, I think first no Wi-Fi is required, as we saw. If your pantograph fails, if your charging mechanism fails, your fleet is not affected. It is just that one bus that is affected, right? So you can still, if you have 100 buses, everything can operate apart from that one bus. That is number one. Number two is that we do see there is a lot of common skills required to maintain that apparatus. So the standard apparatus which is required to maintain your powertrain of a bus, right? The same kind of technical skill set is sufficient to kind of maintain the charger. Reskilling is relatively easy. That is an advantage. Now, the disadvantage is that you need to install a lot more. So it has an implication. So technically, every bus has a charging mechanism installed on top, right? So because of which you have more pantographs, it has an implication on your installation cost, installation and maintenance cost, etc. So there are certain challenges which you need to cater for. That's number one, right? Now, if you look at the right-hand side here, the advantages are very simple. right? It is, you have lower weight because you have one less body attached to your bus, right? And as a result, because you don't need to install it in every bus, there is a lower installation cost, right? But the challenge is, if your pantograph fails, then technically no bus can be charged in that route, right? So something to think about in terms of how you select this charging technology. The good thing is that your current BRT lines, both in Jakarta as well as you go to the new lines in Bandung and Medan, right? You can repurpose your current route where this could be installed, right? Which is, I think, an advantage in terms of as we explore these charging options. Yeah. Can we go to the next slide, please?
Excuse me, Vijal and Rahul, we have 5 minutes left for your presentation. Thank you.
Thank you. Okay, so on this one, we covered the heavy duty parts. Now let's talk about some implications. Number one, your charging technology is very dependent on your battery technology. What does that mean? If you see here, the battery size that you need will depend on the charging technology that you select. And if you see that opportunity charging setup will considerably require lower battery size because you are able to charge it more frequently, right? You're able to charge it more frequently on the road. That is one key message I want to say. Another thing which will affect this is the whole battery chemistry on LFP versus NMC. Currently, what we see is that buses are available in both technologies, right? So you need to, there has to be a marriage between the OEM model and the charging infrastructure that you select. Can you go to the next slide, please? Yeah. So now, how do you take a decision, right? We have so many information that we share. This is a micro market specific decision. What could work in Jabodetabek might not exactly work in Bandung, might not exactly work in Medan. Right? And what is the driver? The driver is threefold. Number one, there is a micro market specific route that you need to say. Is it a small route? It is a medium route. What is the density that you have? Right? That is number one. Number two is what charging speed that you're kind of looking for, because the charging speed will not only impact the speed of charging, but have an adverse implication on battery life. Battery life will impact TCO, as Rahul in the previous presentation mentioned. Right? Depending on your charging depot selection or charging tech selection, your e-bus specification has to change. You cannot use a depot charging with a 100 kilowatt-hour battery. It has to be a 200 or 300 kilowatt-hour battery, which will kind of come into place. How we have solved it is you need to understand consumer behavior, number one, on the right-hand side. Number two, it has to be analytically enabled. You need to understand driving behavior and kind of match all these bits and pieces, and then kind of think about partnerships required. Can we go to the next slide, please? Yeah. So we have examples from India and London. We'll not spend a lot of time there, but important to mention that huge push from government in terms of framing the regulation around charging with incentives. And number two is that it's not a single player game. We see in multiple examples, as you see on the screen, multiple players, OEMs, charging providers, regulators, everybody is coming together in joint collaboration to kind of develop. Yeah. Can we go to the next slide, please? Yeah. This will be my last slide and want to spend 2 minutes here. I hope we have the time, right? There are multiple business models that are existing in this business. Right? One important part, as we see, that the EV OEM value chain runs in parallel with the charging infrastructure value chain. They are not mutually exclusive. You will see multiple times where they correlate and coordinate with each other, right? And the genres of players that we see are as follows, and I will spend 5 seconds on each. Number one, public transport operator. This is a very standard bidding process where we see players involved across the value chain, right? Across the value chain, both in the OEM as well as the charging. You also see the e-bus manufacturer type, which are less relevant on charging, but what they do provide or what they are a part of is involved in managing charging hardware. You have your standard charge point operators who are involved in supplying the OEM side of the charging infra business. Right? You have your charge point operators who have nothing to do with the OEM side, but they completely do only O&M, running the business and taking the money. This is relevant to the retail charging sale business that we have. Two interesting business models to consider is the integrated OEM. Right? So one thing that we have seen people doing is that the OEM, because they are penetrated into the business, they provide not only the bus hardware, but also the charging hardware, and they are involved across the value chain. And the last part of the business, which is the integrated service companies, where we see this is where the business is kind of going, right? The business is mostly dominated by these players. The first one, and the last one, where we see the joint collaboration between players as they shape this up. Right? So overall, that's how we see on some of the key parameters that need to be taken. If there is two messages that I would leave with the group is as follows. Number one is that is the previous slide. If you could go 1 year back again, right? It is a marriage between route. Sorry, one slide before. It is a marriage between route, bus, charging speed, and business model. Right? And it is a customer behavior related decision which might vary by geography. So please spend time in kind of analyzing customer behavior in each of these locations. That's number one. Right? Number two, it is not a one player game. It is about collaboration between multiple players that will actually make this a success, driven via regulatory support from Indonesia. With that, I will pause there and handing it back to you, Vanya. Hope I was respecting the time. Thank you so much.
Okay, thank you very much for your presentation, Rahul, and also Vishal. And we are already get a grasp about the BEB's technology and also the charging infrastructure planning, yeah? And now let's go deeper to the case study starting from Transjakarta, Indonesia experience. I'd like to introduce our next speakers. We have Ibu Faila Sufa as the Southeast Asia Director, Institute of Transportation and Development Policy. And she has worked directly in around 10 countries and over 15 cities, giving technical assistance on sustainable urban mobility, mainly promoting non-motorized transportation, public transport innovations, and also public policies. She has led technical assignment funded by international donors and built strong relationships with a variety of stakeholders such as governments, private sectors, international financial institutions, and United Nations development agencies. She holds a master's degree in transport planning and engineering from the University of Leeds, UK, and also a bachelor's degree in civil engineering from Gajah Mada University, Indonesia. So, Ibu Faila, you have 15 minutes to deliver your presentation. The stage is yours.
Thank you, Fania. Good morning, good evening, good afternoon, everyone. So today I will share the case study from Transjakarta. Before my presentation, I want to provide the context that currently Transjakarta has not implemented e-bus deployment yet. However, there has been several studies already conducted to support e-bus planning, starting from pilot phase, from C40 CFF to scale e-bus deployment, which is funded by UK government. And then for today, I will share TJ electrification program and also continue with the Transjakarta e-bus technology and charging strategy. Next. On this presentation, I will share Transjakarta electrification, which is stated on the Transjakarta long-term plan commitment. And then based on Transjakarta long-term plan commitment, as seen from the figure here, this is a yearly Transjakarta electrification plan until 2030. And as mentioned earlier, there will be more than 10,000 electric bus are planned to be operated by 2030. Next, please. And currently, Transjakarta operates around 248 routes using single bus, low entry bus, medium bus, articulated bus, and also small bus. And then the figure here shows the phases of implementation and the number of fleets for each bus type for the electrification of overall fleets. And the electrification plan is started by electrifying the single bus and also low entry bus, and followed by medium bus, articulated bus, and small bus at the end. As a start, so according to Transjakarta's plan, a pilot project with a total of 100 e-buses will be conducted in 2021. And then the current status of the pilot project, 30 e-bus will be operated for the first phase of the pilot using low floor 12-meter BYD with the battery capacity of 324 kilowatt hours. And it requires the overnight charging at the depot. And hopefully we will soon have this bus rollout in Jakarta next month. And then next, I will explain the Transjakarta e-bus technology and also charging strategy based on study conducted by the ITDP. Yeah, to develop the implementation phases, we use the following methodology. As Transjakarta has like several routes, around 250 routes. So first, we define several typologies of e-buses to scope the analysis, because analyzing all possible combination of electric bus technology on all routes will be very complex. And then in addition to that, it would also be difficult for Transjakarta to have too many variations of electric bus technology on their routes. And it will also add more operational complexity and also costly. And then second, we will analyze the suitable charging strategy at the route levels. And then after we identify the charging strategies, we conducted a spatial analysis to group the routes which have to be electrified together. Routes with have high overlap and have shared infrastructure will be grouped in one group. And then finally, we develop implementation phases considering charging technology maturity and also Transjakarta readiness to provide en-route charging facilities in addition to the depot charging that will be provided by the bus operator. I will explain this table more detail on the next slide. And then actually there are three parameters that we use to define the e-bus technology for Transjakarta, particularly for Transjakarta BRT and non-BRT routes. First, service type operations in Transjakarta, whether this is BRT routes and non-BRT routes. On this study, we only focus on this service type because Transjakarta has more than BRT routes and non-BRT routes. They're also like microbuses and also intercity service. But on this study, we only focus on these two. And then the second is bus type used in Transjakarta, articulated bus, single bus low entry, and also medium bus. And the last is battery size, which is based on market availability on all and bus types. Next, please. Yeah. Based on the Transjakarta's operating system, the e-bus selections is divided into 8 typologies, as seen in this table. The typology is divided into different categories, such as the operational system, whether this is BRT or non-BRT, and then bus type, whether it's single, medium, or articulated bus, battery size, which is based on daily kilometer range, and also the energy consumptions. Next. And then in determining charging strategy at the route level, overnight charging at depots is prioritized due to its lower cost and also lower charging installation complexity. Then we consider opportunity charging using fast charging facilities at the terminus if overnight charging is not sufficient to cover the daily distance. However, there are some routes based on our analysis that were both charging strategies, overnight charging and also opportunity charging are still not sufficient to cover the daily distance. In these cases, we recommended Transjakarta to fully charge the bus during the off-peak periods, because based on Transjakarta's operational plan, there will be only 60% of buses are required in operation at off-peak period. So the rest could be charged their power. Next. And then we compare as well the average daily distance to bus trains to identify routes we can be covered using overnight charging. Based on our analysis, most routes cannot be covered solely by the overnight charging strategies. Therefore, additional fast charging at terminus will be needed to cover on the next step. So this is like a fast charging at terminus will be installed to support the energy requirement for the routes which cannot be covered by overnight charging only. And then we consider the availability dwelling times at each terminus to determine the power output of the fast chargers. And actually, based on our observations, not all terminus can be equipped with charging facilities. So in determining the routes which can be used fast charging strategies on top of overnight charging, we do the analysis of space availability at terminus to install charging infrastructure and also to provide space for bus queue during the charging time. And for the routes where overnight and opportunity charging is not sufficient, there are 4 scenarios that we develop. First is whether we can add more buses or use bigger battery or establish staging facilities on or install flash charging at the BRT stations along the corridor. And we done the TCO analysis, and then based on the TCO analysis, charging at the off-peak period, whether at the existing depot or building new staging facilities along the corridor, it seems more favorable for Transjakarta because it's considering the economics and also the operational aspects. As a summary, based on the analysis of e-bus charging strategy for 124 BRT and non-BRT routes in Transjakarta, we find out that only 14% use overnight charging at the depot, and then 43% use overnight plus opportunity charging at the terminus, and the remaining 43% use overnight, opportunity, and still need additional off-peak charging strategies. And then this is the recommendation for Transjakarta's electric bus implementation phases. Based on our analysis, there are 4 phases for the implementation, 5 phases, sorry, for the implementation until 2030. We can see from the next slides. The implementation phase actually developed by considering technology maturity and the amount of investment. Routes that are served by overnight charging strategy, which have the least investment cost and operational risk, is prioritized for the early implementations. And then next, and then most charging facilities are provided at the later stage, for example, phase 3 and phase 4, and then next, yeah, and then the articulated buses can be held back in the operation for the later stages, the last stage, since the technology and market availability is not yet clear. I think that's all for my presentations today. Thank you very much.
Thank you very much,
Over to
Ibu
you.
Faila. Yeah, thank you very much, Ibu Faila, for your presentation, and we will discuss further, ya Bu, on the Q&A session. Thank you. So, ladies and gentlemen, from Indonesia, there is also a case study from Bangalore, India, that will be delivered by Ray Minhares, and I will introduce Ray Minhares here. He is the Heavy Duty Vehicles Program Director at the International Council on Clean Transportation, and he managing a global team of researchers supporting the transition to a soot-free, low-carbon, and zero-emission commercial truck and bus fleet across major vehicle markets. Mr. Minhares has over 15 years of experience in environment, energy, and transportation policy at the city, regional, national, and international levels. So Ray holds a master's degree in public health from the University of California, Berkeley, and also a bachelor's degree in international development, environmental studies, and philosophy from the University of California, Los Angeles. So to Ray, you have around 15 minutes. If you can do less than that. And please, the floor is yours. Thank you.
Okay, thank you, Vanya. That was very generous of you. So I'm going to begin my presentation with a couple of questions that surely every operator has before they've started deploying e-buses. Which vehicle should I purchase? Number one. What charging strategy should I deploy? Because we're assuming at the beginning these are battery electric, not fuel cell. In fact, the vast majority of electric zero-emission buses sold today in the world are battery electric, they're not fuel cell. What solution that I choose will match my existing diesel performance, because if I'm deploying an electric bus, I want to deliver the same performance. I don't want to deliver less performance. Actually, I prefer to even deliver better and more performance from this technology. And finally, how do I achieve all of this at the least cost? So those are the framing questions for what I'm going to present today. Next slide, please. We at the ICT, together with partners at UITP India, assessed these questions for a set of routes operated by the Bangalore Metropolitan Transport Corporation, BMTC. They are the public transit provider for the city of Bangalore, India, one of the largest cities in India. That fleet has more than 6,000 vehicles, more than 40 depots, so 45 total depots, more than 30,000 staff. And to date, the fleet has contracted for the deployment of 90 non-air conditioned buses. And that fleet of 90 buses will be deployed on a leasing model. So they will not purchase, but they will lease these buses. Next slide, please. So the path that we assessed has these three basic steps. The first step was to identify which are the vehicles that are already being offered in the market in India today. So we start from the vehicle perspective, understanding what is the typology of the bus as well. And so there will be several options in the marketplace. For example, a 9-meter bus versus a 12-meter bus, an AC versus a non-AC bus. Those types of items are open for consideration. And so we start with what basically does the market already provide that I can choose from? We follow that with the selection of the depots that are the priority locations for the installation of these buses and their charging infrastructure. Those depots are selected based on the availability of space. As Faela was mentioning previously, space is a very key factor. The proximity of the depot to power infrastructure is also a key factor. The closer the depot is located to, for example, a substation, the less cost that will be to transport high power. And so depot location is key. And finally, the routes themselves. So just like other speakers, we focus on the routes and their performance. And the question here is, if we have a particular e-bus model and we know the location of the depot from which it will operate, which routes will that bus be able to fully electrify? And are there any limitations with respect to the charging that we have to overcome in order to deliver that diesel equivalent range and performance? Next slide, please. We selected a 322 kilowatt hour battery and a 12-meter bus. This lists the other specifications, but I won't go into the details. The right-hand side figure is an illustration of an energy audit that we conducted. So we found that this 12-meter AC bus delivers an energy efficiency equal to around 1 kilowatt hour per kilometer. In comparison, the equivalent diesel bus is greater than 3, close to 3.5. So that's an illustration of how much more energy efficient the battery electric bus is. That energy efficiency helps to explain why these buses have a lower total cost of ownership on average than their diesel counterparts. Next slide, please. This is a map showing all of the depots, the 45 depots that serve the BMTC fleet. We developed a scoring system that provides, let's say, a way to measure the attractiveness of locating battery electric buses at that depot. So you can see in this image, the size of the circle represents a higher score, which is equal to a higher attractiveness and feasibility for battery electric bus installation. Next slide, please. And together with that selection of depots, we then filtered to a smaller subset of depots that were serving particular routes. And we, in this analysis, focused on a set of long distance airport routes. Those are also some of the highest earning routes. So from a cost effectiveness and return on investment perspective, we saw airport routes as very attractive for electrification. But we also selected a set of urban routes, both considering routes that could be supported by AC buses, but also non-AC buses, with AC buses providing a kind of premium urban bus service. Next slide, please. And so the result that we arrived at with the routes was a set of 29 routes. The average length of the routes for urban transit services were about 30 kilometers. The airport routes were about nearly twice as long, about 55 kilometers. On average, the urban routes had about 12 buses serving them compared to 6 for the airport routes, and so on. And so this table provides more information. We applied our understanding of the energy requirements of the routes themselves to simulate the performance of a battery electric bus on each one of those 29 routes. And we compared that to the diesel. So the end result was that, like I showed previously, the battery electric buses were much lower energy consuming compared to the diesel. And there was not a large difference between the AC and the non-AC. So, for example, in this slide, we're showing that the non-AC buses achieved a performance about less than 1 kilowatt hour per kilometer, while the AC buses were just slightly above that and maybe between 1 and 1.25. Whereas the diesel buses were, you know, on an equivalent basis, more like 4 to 4.5 kilowatt hours per kilometer on average. And that range is impacted by the passenger loading, which we found was had a linear relationship to energy consumption. Next slide, please. So now I'll present the final results of the charging strategy. First, to make a point here that we cannot take the manufacturer's claims of range as the real world performance of the vehicle. So in our analysis, we took into consideration 20% reserve state of charge for the battery. We assumed 100% passenger load. We also took into consideration AC load, and we added a battery degradation factor. So we assumed that at the end of the vehicle's life, 80% of the original battery capacity would be available. So this illustration shows for 2 of the routes we modeled. One is the airport route in green, the other an urban route in red. That for the airport route, the theoretical maximum range is 468 kilometers. But when we take into consideration all of these factors, the range that we get is 148 kilometers. And so we wanted to do this analysis reflecting this, let's say, worst case scenario. Next slide, please. So one of our main conclusions here was that of the 29 routes that we evaluated, the 322 kilowatt hour 12-meter bus could support 6 of the existing routes with a single depot charge and nothing more. That means that BMTC can today begin to electrify the entire set of 6 routes with the bus that we evaluated. However, we found that 11 additional routes could not be supported, and that primarily was due to our assumptions on battery degradation. And finally, we concluded that a single depot charge could not support the electrification of any of these airport routes unless other considerations were taken into account. So that's what I'll present on the next slide. So next slide, please.
Excuse me, Ray. We have 5 minutes left for your presentation. Thank you.
Okay, thank you. So in order to overcome some of these range limitations, we made an assumption that a 50 kilowatt hour single midday charge could be available. In Faila's earlier presentation, she showed how there could be an opportunity charge during the day. This would be equivalent to that. So a 50 kilowatt hour midday charge in our analysis would allow 10 additional routes to be fully electrified by the existing bus, by the bus that we evaluated. So that is one way to overcome the battery degradation factor that I illustrated. But still, the battery degradation would exceed the daily range requirements of 3 routes with that 50 kilowatt hour midday charge. That could perhaps still be overcome by a slightly longer charge that we did not evaluate, but I think that is certainly an option. But the single depot charge plus the midday was insufficient for 10 total routes. And so we still have other limitations to take into account. Next slide, please. So the final result for us here was to show that particularly for replacement ratio, we were trying to avoid replacing each diesel bus with more than one battery electric bus. So we found that a solution in 17 out of the 20 routes where we could maintain that replacement ratio of 1 or less. but that is made possible primarily by the availability of the en route 50 kilowatt hour midday charge. The solution, that was not an appropriate solution for the airport routes, and to fully electrify those, one has to go even further. And so that could include a faster, larger midday charge, but it could also include an entirely different vehicle that has a larger battery, for example, and other potential solutions, including deploying more than one battery electric bus for each diesel bus. But that just illustrates for you that in each one of these routes, there is a simple way to start the analysis so that you can, let's say, put aside the routes that you know can be fully electrified with the commercially available buses on the market today with a single depot charge. That is the very first and the easiest step, the most logical step, before we get into any of the other solutions. So to me, that is the recommendation with any transit fleet. Next slide, please. So in conclusion here, we begin with the products commercially available. We identify the depots where we can locate those buses. We focus on those routes served by these depots, and we focus those early deployment on the depot charging only. That allows us to then electrify a minimum percentage of the fleet immediately, so that we can then move to design additional solutions for en-route charging and other vehicle types that might be available. I'll stop there. Thank you, Vanya.
Yeah, thank you very much, Ray, for your presentation. And we would like to invite again our speakers in the first module, because after this we will have the Q&A session where we will answer several questions from our attendees here. So I would like to invite again to Rahul Bhaktia, to Vishal, and Rahul Gupta, Ibu Faila, and also Ray to come join us to the stage. And then I would like to go through the first question. So the first question will be for Rahul Bhaktia. And the question is about the data. Many bus operational data of Indonesian public transport fleet is still collected manually or not collected at all. Which data should be prioritized to be collected to enable the e-bus fleet planning? Rahul?
Sure, thank you, Vanya. I think the question was like, what data collection will be very useful for e-bus planning? Yeah. I think that's a very important question. Many of the people believe that you need to have an e-bus running on road in your city to be able to collect data from e-bus operations, the range and other part. And then you are able to decide upon the scaling of the pilot. With the kind of advancements in analytical modeling and simulations that has arrived. I'm saying, yes, it's a very important point. Many of the cities, they struggle and they don't need to have an e-bus to start with a pilot. They can collect the data on their existing diesel buses. As Ray, even Rahul and Vishal also pointed out, the need for a kind of credible duty cycle, right, which will allow you to do a route analysis for e-bus implementation. That is good if we are able to capture the duty cycle, which means basically the velocity, time, and space distance relationship of existing buses. So simple mobile device can also be used on a running e-bus to capture those duty cycles on a specific route. And they can be analyzed for calculating the energy consumption of e-buses. And I think that really brings a very high specificity rather than making assumptions on kilowatt hour per kilometer in different scenarios of loading, AC on off, and all other things. So I think that is one, I would say, one most important data point that can really help e-buses implementation. Second point, which I see a miss in many of the implementation e-buses coming more from the Indian experience, of existing e-bus deployment, we are not measuring enough data points around the charging stations. If we can bring a right kind of monitoring, like at the charging stations, which is very easy with the kind of IT system that now exists, which you are able to record and be able to index, like what bus, what SOC, what kind of kilowatt hour went into it, how much time it took. Those data points are very, very important to kind of bring about and study the degradation pattern, which Ray was pointing in his analysis. And it also kind of helps plan the operation and charging cycles better. So I think these two things, I think, would really make very important difference.
Thank you very much, Rahul. So to the next question, this is, I think, for Ibu Faila. So the first question is, based on your study, which corridor is the most suitable for a successful early e-bus deployment, considering the existing and planned infrastructure book?
Yeah, so to have like the overall whole analysis, we already published our study on our website. There is a overall scale up of the BRT and non-BRT Transjakarta e-bus deployment, but to answer that question, actually based on considering several factors like daily distance, and then grid networks, depot location, market availability, and so on. So we found out that corridor 6 and 9 will be the corridor that could be, but mostly in corridor 6 electrify first. But the electrifications, the first electrification of Transjakarta, actually it's not only on the technical side, maybe like for the campaign purposes, showcase to the public. If that's the case, there's also another corridor, which is corridor 1. So I think it's like a lot of decision should be considered in this, mainly on the pilot, but based on the what is it called, technical analysis, the first routes or corridor that will be ideal to be electrified first is corridor 6, and also some of corridor 9. And the overall study can be seen in ITDP's website.
Okay, thank you, Bu Faila, for the explanation. So the next question, I think I would like to go to our discussion on the chat box. I saw that there's a question from Nupur, yeah, about the availability of depot charging for to provide the charging for BRT. Nupur said that, yeah, maybe like we saw in Transjakarta case where we can only rely 14% of the buses that could rely on depot charging versus the others that would require others. And then Nupur also asked about, could we conclude that only depot charging is unlikely to be sufficient for BRT operations in most cases? I think I will address this question to Rahul and also Vishal. So Rahul Gupta and also Vishal.
I think it's difficult to say, right? That I don't think it is a black and white statement. And the reason I say that is because let's say you're doing a greenfield project in Medan in Bandung, right? What is the route that you're planning for? Is every route less than 50 kilometers? Right? Is there a 200-kilometer route? Is there an airport route? I think I'm just echoing the points that Ray and Rahul mentioned, right? So there is a bit of route angle that you need to consider. Number 2 is which OEM are you actually bringing in, right? Are you bringing in a vehicle with a range of 300 to 400 kilometers? Are you bringing in a vehicle with a range of 100 to 150 kilometers? And what's happening there? right? And then again, echoing Ray's point, actual range versus theoretical range versus practical range, there is a gap, right? So at some level, to be able to answer that question, how much is depot and how much is opportunity, will depend on this combination of your customer behavior, route, and the OEM that you select. Only then you will be able to say whether it is 15%, 20%, right? It will be a bit challenging to answer that in a black and white without understanding those two parameters. Yeah, Rahul, if you'd like to add something.
No, I think you've covered. I think it's understanding the route, understanding the charging infrastructure, the providers who are providing those vehicle types, and what is the vehicle range and capacity, right? With that, all the interlinkages, which I think Vishal was explaining, that those interlinkages needs to be looked at to define what is the right charging infrastructure solution.
Okay, thank you for the answer, Vishal and also Rahul. So I think this is a very case-by-case situation, right? We cannot conclude right away about that. Okay, so I will go to the next question. I would like to ask to Ray, maybe to build a sustainable e-bus charging ecosystem in Indonesia. What are the key steps that need to be taken by the governments, considering the limited financial capacity of the public transport operators, apart from subsidies? Yeah, who are the key potential players that need to be engaged, right?
Well, thank you for the question. So charging is a key success factor. Vehicles and fuels are a single system. We cannot have electric buses without charging. There's no question about this. So the question really is, how do we build a sustainable charging ecosystem? There is a role for the government in that. In fact, one piece of research the ICCT will soon release identifies the 5 key policies governments can pursue in order to support electrification of all heavy-duty vehicle types, including buses. And one of those 5 key policies is the establishment of infrastructure programs and policies. The government has a role to play in defining standards and adopting standards for charging systems. The government has a role to play in investing in infrastructure for charging, especially publicly accessible infrastructure in locations that are owned by the government, so on public land and public property. Those are ways in which the government can immediately invest in infrastructure. Now, specifically for buses, of course, some public transit agencies, and here I'm thinking about India in particular, are entirely owned by the government. So it's always going to be a government action. In Indonesia, of course, we have a mix. We have transit agencies and operators that are publicly owned, like Transjakarta. We also have privately owned operators. And so to your question about those who perhaps don't have the resources, yes, it is challenging. There's no question for them, especially if the government is not there to support them with the infrastructure. And so there is already, as we've discussed in this workshop, a presidential regulation 55/2019, which is key to develop the supply for the market, but that can only go so far. And on the infrastructure side, the government does need to make investments in the infrastructure. The government does need to set tariffs that are going to be attractive to help lower the total cost of ownership for electric vehicles and provide direct subsidies for the purchase of those vehicles. Finally, there are ways the government can adopt actual sales requirements on manufacturers, as well as purchase requirements on fleets. So there's a whole range of policies, and I don't have time to go into all of the details of them, but I hope it's clear that there is a key role for the government that requires planning, coordination, and investment.
Yeah, thank you, Ray. I think we are all in the same page that the government can set the environment for EV buses development in Indonesia. And then I think this is the last question for this module, for this round. And I will address this to Rahul Gupta or Vishal. So the question is, to what extent is the importance of defining a single charging infrastructure interface standard, especially for plug-in chargers? Given the regional market, what is the recommended standards?
Standards go hand in hand with regulation. I think that's number one. I think what we see in a lot of these different geographies, right? Early adopters of EVs, I think standards help, right? And as Indonesia being at a nascent stage right now, it has an opportunity to carve that a bit, right? What is a bit of a challenge is currently EVs are predominantly an import-driven market in a lot of these developing economies, including Indonesia, right? And each of this vehicle coming from their different geographies come with their respective standards. Chinese vehicle will have a Chinese standard, a European vehicle will have a European standard, right? So it's important to consider as you frame the roadmap for Indonesia, right? As you frame the roadmap for Indonesia, what do you know, there has to be a tipping point in which you decide that this is the standard regulatory basis on the for my charging plug, right? Whether it is a CCS, CHAdeMO, Chinese, it's indifferent. That is not the problem. The point is, you know, what if you standardize it, it also incentivizes different OEMs to kind of support you in that direction, right? A standardization will help you in optimization, right? Imagine you have a charging provider with 5 different OEM models with 5 different charging plugs in the country as compared to 1, right? So with that scale, you will be able to further optimize your ecosystem, right? Further optimize your ecosystem, thereby able to drive that upside in charging infrastructure when you talk about margins, revenues, etc. So that is that advantage where we get at. Now, if the question is which is that standard which Indonesia should adopt, I think it's a bit premature for us to be able to answer that question, right? That should we follow one over the other? Right? I think it's a journey which needs to be figured out. It's not something which can be answered at the get-go at the moment.
Okay, thank you, Vishal. Maybe Rahul Gupta, would you like to add?
No, I think Vishal has covered nicely, so no additional point.
Thank you very much. So we cannot really recommend, yeah, which kind of plug that we should standardize for Indonesia right now, especially when we are still in the early stage of adoption. And okay, thank you very much for all of the speakers for our first module for today. Thank you so much, Rahul Bhaktia, Rahul Gupta, Vishal, to Ibu Faila, on also to Ray. So, ladies and gentlemen, we would like to continue our discussion to the second module, that is business model and financing mechanisms on EPAS deployment. So that was our first session that we have talked about the technology of battery electric buses and also the charging infrastructure. And now in the second session, we are going to look deeper at the business model and also financing mechanisms. And for the first presentation in this module, I would like to introduce Anthony Courage as the Senior Manager at Clean Transport Finance at C40 cities. He has been supporting the adoption of zero-emission transport solutions around the world by working closely with municipal authorities and financial institutions. And he has gained particular experience developing and implementing innovative commercial models for e-mobility, focusing on e-buses and charging infrastructure. So, Anthony, we have 15 minutes for your presentation. Feel free, the stage is yours.
Thank you, Vanya. Thank you very much. Thank you for inviting me as well to present on this panel. My presentation is really, the objective really is to give an introduction to these models. Now we've talked about the technology. Now we're going to figure out how to procure these vehicles, these assets, this infrastructure, and those solutions in general. So my presentation is really not going to go into the details of which city adopted what solution, what has worked, what hasn't. I'll leave that to my colleagues in the presentations later. But really, my presentation is more about an overview of the alternative models out there that can help cities overcome some of the challenges that we've actually just talked about. Okay, so the first question is, why are we talking about this? Why is it that cities need what we call alternative business models? Because it's not necessarily intuitive. Why would cities not be able to continue procuring vehicles and infrastructure the same way they've been doing it for the past, in some cases, 100 years? So why do we need those alternative business models? Well, the reality is, when we talk about e-mobility, there are very specific challenges that are new and that cities haven't really encountered before, or at the very least haven't encountered to the same degree that they do now. The first one is the high capital cost. We talked about earlier on about the total cost of ownership. So there is a reality that electric buses and their batteries and their infrastructure cost more not on a total cost of ownership basis, but in terms of upfront cost. So upfront cost, the cost that comes at the very beginning in terms of capital expenditure. The second one is the local expertise. So we know once again that the reason we're doing this webinar today, and the reason we're talking about technology and talking about business models, is that in many cases cities and governments lack the technical and financial expertise to implement solutions that are more technologically advanced than what they're used to. And then we have the technology risk. So reliability of electric buses and the uncertainty, as my colleague Ray just mentioned, about in terms of battery degradation, and there's a lot of uncertainty around battery life, and that's a big risk for cities. Are the batteries going to deplete or lose more than 70%, 80% capacity in 3 years, in 5 years, in 8 years, in 10 years? So there's a lot of uncertainty that brings a lot of risk. And the operational risk. Are my buses going to be able to complete service as required? And then there's a risk around charging infrastructure. Again, that is new. The cost of the charging infrastructure and unclear responsibilities amongst city stakeholders, this is something that is new. So a lot of cities are struggling with that. And finally, we also see a lot of delays around public procurement. It may not be true in Indonesia, but it's certainly true in many parts of the world where the public route often is far more time intensive than other procurement routes. So we know that there are specific risks that come with electric mobility. So the other thing is that it's also not just the risk themselves, but who bears those risks. And what we see is that the owner operator, under a current model, under a traditional model, most of the risk sits with the owner operator. Most of the financial risk, so if we look at the owner operator being in blue, with the financial risk, most of that is with the owner operator. Most of the demand risk also, the demand that is fluctuating, especially now in an environment where COVID has really considerably affected demand for public transportation. So we see that who bears the demand risk and the lack of the decrease in the fluctuation in revenue associated with that. Well, in their traditional model, that demand is also something that the owner operator has to bear. Technology, around battery life, battery expectancy, and range degradation, most of that is something that sits with whoever is the owner operator of the vehicle. And availability, again, is the bus going to complete the route? Is going to meet service demand? That is also something that is with the owner operator. So, a risk allocation that is not really fair and that is heavily concentrated on this concept of owner operator, an entity that owns and operates the vehicles. So what we propose and what a lot of cities have started implementing is a model that will involve a third party to share responsibility. So basically, we go from a model that relies on what I've been talking about, an owner operator, which is a single entity that owns and operates the fleet, and bears responsibility from everything, designing, building infrastructure, financing, ownership of the assets, operation of the assets, maintenance, end of life. So we move from a model like that we call a bundled model to a model that we can call unbundled, where we bring a third party asset owner that can take care of some of the responsibilities. And so alternative models, those models, what we can call unbundled models, we call alternative delivery models, they can be pretty useful to better distribute risk between the different parties. So this is the old model. Okay, this is the traditional model, and if we focus on the blue bars, which is the owner operator, and we move to look at what this risk allocation looks like under the new model. Well, we see that the risk allocation is much more fair, and in particular, the fleet provider, so this third party that we've been talking about, the fleet provider who can come in and actually be the owner of the assets, well, that party all of a sudden starts to bear a lot of the risk. And that is fair. That is a more fairer distribution of risk between the different parties. So this is fundamentally the point here of introducing a third party. So what does that look like? Well, again, don't get overwhelmed by a lot of boxes and a lot of arrows that we see here. This is basically a traditional model. So we have a municipality and transit authority that basically is in charge of everything from all, funding in the beginning, collecting taxes, collecting user fares, financing, procurement, and operation. And that's also true in a model where the municipality relies on a private operator to do that. So this is, depending on the city, depending on the context, we'll have different models, but those are the traditional models. And what we see is, again, we have risk allocation of, heavily concentrated on one entity. So again, we propose to bring a third party, and this is what it looks like. We have a fleet provider that becomes the entity in charge of financing, procuring the assets, dealing with the infrastructure work, you're dealing with the suppliers, the bus manufacturers, charging infrastructure manufacturers, also dealing with investors. And then they are in charge of everything that we've mentioned before, from designing the infrastructure, building it, procuring the vehicles, financing, ownership, maintenance, end of life, everything. And then we are left with an operator who does what they do best, effectively, which is to operate, right? And a municipality who then has one availability payment with a fleet provider, and another payment, which we can call the operations payment, with the operator. So this is really what this model looks like in a diagram form. Now, I think really the point of my presentation, and my colleagues in the subsequent presentations will go into these models in greater detail, and they'll talk about how these different models were adapted to the different municipal contexts. But that's not the point of my presentation. So really, what I want to convey here is that if you notice, I haven't mentioned buses, or maybe I did by mistake once or twice, but it's really not about. It's really much wider than buses. It's a way to procure infrastructure, and in this case, transportation assets. So there are multiple variations. And if we look at, in the case of buses, because we'll take an example of buses, this is what we're talking about, the additional CapEx associated with electric buses. We know that in terms of capital expenditure, so CapEx on day one, electric vehicles, electric buses are more expensive. So the question is, how do we overcome that, and how do we finance that? Well, the point of this presentation is to say that there are multiple ways to do that. There are multiple ways to procure this infrastructure. So one is really to outsource everything. So everything from the vehicles, the batteries, the charging infrastructure. And another option is to do battery and charging. We don't have to outsource everything. It can just be the batteries and charging infrastructure, but it can also be just the batteries, which is option 3. And it can also just be the charging infrastructure. So the point is, if we are to engage a third party, private fleet provider or asset provider, that asset provider can provide anything the city wants provided. And it doesn't mean that the city has to give up control over everything. When I say the city, it can also be the operators, the private operators. It doesn't mean to have to give up control over everything. It can just be a portion of the asset. And in particular, it can be the most troublesome portion, or the one that they don't want to deal with. So again, here we're talking about multiple different models. And you might have heard of the concept of fleet as a service, for instance, where the fleet provider, the service provider, as we may call it, is going to take care of the charging infrastructure, is going to take care of the batteries, the vehicles, and is going to offer that to a municipal entity and will receive availability payments or lease payments, if we prefer, in return. So that would be a fleet as a service. But we can also have battery as a service, where the only thing that is outsourced, the only thing that a service provider will offer are the batteries. And everything else, the rest of the assets, will sit with the traditional municipal stakeholder, whether it's the municipality or the operator. And we can also have charging as a service, where the same system applies to the charging infrastructure. So again, there's a long many of the different options that are possible, including transportation as a service, where we have everything, including the energy, including the electricity. And the good thing is with here is we can even add renewables. So there's really a number of different options that are available. And I promise you, there's a lot of very innovative private companies out there that have put together service packages that can really be tailored to the needs of a city, of a municipal entity. Now, what I really want to mention here is that these models will be sold as turnkey models. They will be sold as models that, remove risk or take risk away from the operator, take risk away from the municipality, takes the financing risk away from the municipality, from the operator. But it's quite clear that the municipalities also have a very important role to play here. So it is true that, we're talking about reduced. Yeah.
Yeah, could you jump to the conclusion, because we still have like 2 minutes left for this presentation. Thank you.
So we're talking about reduced capital cost and the better allocation of risk, which is also what we mentioned in this presentation. Everybody focuses on their core business, focusing on what they're good at, accelerated delivery. So no, those models are clearly a powerful tool for cities, and those are really the key benefits here. But we also have complex structuring. We looked at these models; they're not easy to structure, and in particular because they involve private investors, we need guarantees. It means that cities have a lot of work to do to create guarantees, to create payment structures that make investors feel secure. And there's also a need for close monitoring, because by outsourcing services, there's a need for cities to very closely look at the delivery, look at the performances of how these services are delivered. And then there's a question of value for money that can also be hard to determine. So a powerful tool for cities, but a tool that requires careful planning and management. So conclusions. I think, as I've said before, unbundling transit models can help distribute risk. So separating ownership of the assets from the operation of the assets can really help cities distribute risk, especially when talking about electric mobility. Number two is the elevated capital expenditure. The CapEx don't have to be a barrier. We know that in many cases it is perceived as a barrier, but there are models out there that really can help alleviate that and can help shift that CapEx pressure onto a third party. The third thing that I mentioned during the presentation is there's really more than one way to procure infrastructure, and especially in the case of mobility, there's multiple assets that are very different from each other, whether we're talking about buses, batteries, charging infrastructure. So there's really more than one way to procure it. And finally, these unbundled models, they present amazing opportunities, but they still require close involvement from municipalities. And then we'll stop there.
Thank you very much, Anthony, for your presentation, and we will connect again at the discussion session where we will answer several questions for our participants. So, ladies and gentlemen, up next, there will be a presentation about case study from Chile. So here I would like to introduce Jenny Lopez Ramirez as the director of Mario Molina Center. And a private sector focusing on R&D in energy and environment. And he has more than 20 years of experience in environmental management and environmental technology deployment in Chile and in Latin America. To Jenny, so we have around 15 minutes for your presentation. Hopefully we can do less than that. And the floor is yours.
Thank you, Vania. Thank you very much. Thanks for the opportunity to share the experience of Santiago, Chile. That we have around 1,000 battery electric buses running now. And Anthony made a very good framework for the presentation that we made, like an example of the use of different business models that can facilitate the deployment of this new technology. We are a research and development in an innovation center, and we are very focused on air quality, climate change, and energy and transport, working from the year 2004 in Latin America, all over Latin America, promoting more advanced technology to reduce the air pollution problems and the climate change problem. Next slide, please. Context to understand a little more about Santiago. Santiago, Chile has roughly 6 million inhabitants, and we had around 4 million daily public transport trips. And we have 6 bus operators that are private companies that work together and have large subway service with 7 lines plus 1 urban train line. And this is interesting because it's connecting with the introduction of Anthony. In the case of Santiago, we have the responsibility of operation in the Ministry of Transport, but the operation is in hands of private operators, 6 large companies. Next slide, please. The business model that started in the year 2006 is through a tender process. Ministry of Transport contracted 6 large bus operators with a fleet of 7,000 buses. You can see here the different operators, the different companies sharing roughly each one of them between 10 and 20% of the fleet operating in the city. And you can see here the traditional model in terms of the Anthony presentation, where the authority that is in the case of Santiago is the national authority. The Ministry of Transport is responsible for the operation of public transit system in Santiago. They contracted the private operators through a tender process, and the operators are in charge of all the things, including bus depot, the buses, the maintenance, and the operation. This is the traditional approach. And this is currently in operation for more than 10 years with diesel buses, but the model is changing, facilitating the introduction of electric buses, solving the barriers that Anthony mentioned. Next slide, please. First of all, it's very important to have a broad approach to clean buses before the introduction of battery electric buses. In the case of Santiago, next slide, please. We have a large history in cleaning up the bus fleet because the city of Santiago has a problem of air pollution from many years ago. And one of the key sources was public transport. And there are a large experience introducing more clean fuels. We have 15 ppm sulfur diesel for more than 10 years. And also in parallel, we are introducing more advanced technology in diesel buses. When you have more advanced or more strict requirement for diesel buses, you reduce the incremental cost of the battery electric buses in comparison with the conventional diesel buses, because the cost of a new Euro 6 bus with plenty of technology for emission control for particulate matter and NOx that bus with the highest standard of technology has a higher price compared to a Euro 3 diesel bus. If you are requiring Euro 6 buses, you have more conditions for battery electric buses because the upfront costs are not too higher in comparison with a market where their standard are just Euro 3. Next slide, please. You can see here what is the composition today of the fleet in Santiago, and we have 7,000 buses roughly. 11,000 of them is more than 11,000 today. This is at the end of the last year. Are battery electric buses, but 21% is Euro 6 buses. Next slide, please. We started with pilot project to understand the technology to make and to overcome the different barriers beyond the financial issues, mostly in terms of operation and range of the buses. What are the more appropriate routes? That was the discussion in the previous panel. We made all that discussion using different pilot projects and different studies using modeling and different alternatives to understand what are the best way to introduce the buses. And we started in the year 2012, and we scale up for more than 100 buses 5 years after that. Next slide, please. And this is the most interesting slide in connection with the Anthony introduction. This is the business model that is enable now the introduction of battery electric buses. You can see here the different stakeholder. You have the transport operator. In this case, is one of the largest companies that is called Medbus. That is a private company with more than 1,000 buses. Roughly 400 now are battery electric buses. All of them BYD for China. There are other operators using U-Ton buses. There are other using Photon buses, different suppliers from China. And we have the public body playing a very important role, the National Ministry of Transport with the Transport Authority for the City of Santiago. They are in charge of the contract with the authorities, with the operators, but also they are controlling the operation of the public transport system of Santiago that includes a financial administration agency that distribute all the resources that are available for the system, that include the incomes from the fares from the passengers, plus the subsidies that came from the national government. The system is roughly 50% subsidized by the national government. And in the case of the introduction of battery electric buses, we have the third player, that is the asset manager. In this case is a utility company, NLX from Italy, but it's a company that is in charge of distribution of electricity all over Santiago, city of Santiago. They are providing the asset, including the buses and including all the charging infrastructure in this specific case for the operator that are mentioning here, that is Medbus. In other cases, there are other private operators that are using buses that are provided through leasing, through different asset manager. For example, from Engie, a French, Belgian utility that is also involved in the business here in Santiago, providing buses to the private operators. And you can see here all the things that we was discussing before. We have the OEM, the bus manufacturer, BYD, that has a contract with the asset manager, that is the utility, the NLX. NLX has a contract with the Financial Administration Agency, and they are also on a leasing contract, including buses and chargers with the operator, with the private operator, in this case, Medbus. And also they are in a relation between the OEM, the bus provider, with the operators in relation with the maintenance. There are, in this case, a monthly payment in relation with the maintenance of the buses and all the service that the buses requires for the operation.
Excuse me, Johnny?
Yeah, yes.
We have less than 5 minutes for your presentation. Thank you very much.
Yeah, okay. The other key issue in Santiago that is so important to understand is there are a fleet-wide strategy from the government. It's not just one specific process for one or two operators that runs in some routes. They are targeted for the full electrification of the public transport system in Santiago by the year 2035. And there are a tendering process now by the Ministry of Transport that wants to introduce roughly 2,000 more battery electric buses by the year 2022. And this tendering process include all this new approach, including a third stakeholder that provide all the assets, including infrastructure for charging and also the buses. And this is part of the national approach for the promotion of electric mobility and the speed up of the deployment of the technology, including private cars and more than that. I will stop here, and I'm ready for question and answer. Navia, thank you very much. That's
okay, all. Thank you. Thank you very much, Jenny, for the presentation, and we will continue again later on the Q&A session. And then for the next presenter, we will have a case study from India, from Chile. We are now moving to India, ladies and gentlemen. I would like to introduce our speaker. He is Ravi Gadepalli. He is an independent public transport consultant with ITDP and the World Bank based in Bangalore, India. His recent work is focused on planning, procurement, and implementation of electric buses in India, along with data analytics for bus network planning and scheduling. Ravi has 13 years of experience working as researcher, consultant, and philanthropic fund manager on transport policy, planning, and advocacy projects. And he is actively collaborating with government and industry stakeholders. So to Ravi, we have 15 minutes for your presentation. I hope you can do less. And the floor is yours.
Thank you, Anya. Thanks for the generous introduction, and to the organizers for inviting me to present here. So I'll broadly cover 3 big topics which may be of help for Indonesian electric bus procurement or implementation. So learning from the Indian experience, what are the key incentives we can give to accelerate electric bus adoption? What are the key cost drivers of procurement? And then the procurement specifications itself, which can be improved based on the Indian experience or the other experience we have seen around the world. So firstly, the incentives. So in India, we have this scheme called the Faster Adoption and Manufacturing of Electric Vehicles, called FAME, which is the government of India's flagship scheme. For the buses specifically, this included capex incentive on the vehicle cost itself. And then there are other regulatory incentives which I'll come to later. So this evolved over the years. So it's still quite recent. It's only 4 years old, specific to the buses. The first 2 years was a bit more open-ended. We had a single value of $140 subsidy, $140,000 for any bus, whether it is a 9-meter bus or a 12-meter bus, or any bus city wants to procure. The only differential was the amount of localization or the percentage of components manufactured in India. So it was just like a pilot, and it supported 60% of the vehicle cost. What we saw was that the uptake was limited. It was around 425 buses across India, and there were another 150 buses procured by the cities using the similar template. But we saw significant variation between costs between cities, and also many times the cities tenders going into court litigations and stuff. So the next round of FAME actually standardized the whole procurement exercise and also calibrated the subsidy. So because the vehicle prices were coming down, the actual subsidy was also reduced to up to $80,000 only. And it was varying based on the vehicle length. So what we saw in FAME 1 was because it was a vehicle agnostic, many cities procured smaller buses and still availed the same subsidy. So to avoid that, it was linked to the vehicle length, and also the cost of the vehicle, only 40% of it was supported in the second round. So, and the other key variation is that, if you can just stay on the previous slide, the other key variation on this, on FAME 2 was that gross cost contracting was the one business model which is mandated to be adopted across the country, and a model concession agreement, which the agreement between the authority procuring services and the operator or the service provider providing the services, it was standardized, and only a few operational parameters were left to the city. So that way, as a service provider, you know across the cities that there is a standardized way of procuring things. So there's much more clarity. So which led to many more buses being procured this round, around 3,200 buses, out of which around 800 are already operational, and the rest are agreed upon and they will be delivered soon. And then the next round of procurement is just starting. In the next round, the similar template will be followed on the subsidy structure and procurement, but just the cities are predefined. In parallel to the financial incentive, Government of India has done a lot of regulatory changes also. So first was in the initial years, just to increase adoption of electric vehicles, there was much more focus on import-oriented deployment, where there was only 15 to 35% localization required. By FAME 2, it increased to 40%. Localization means the number of components sourced and manufactured in India. And later on, by last year, 2020, we now have a phased manufacturing program, which mandates most of the components to be made in India. And separately, there are tax incentives and disincentives around that. There is the GST, the goods and services tax on procurement, which originally was 28% on electric vehicles in the initial years. Before 2017, it was reduced to 18% and then to 5% on the vehicles. And for batteries, it's still at 18%. And also the customs duties on the basic customs duty and the customs duty on commercially built units, the semi-knockdown and completely knockdown kits. So that kept changing. So initially that was reduced to attract more imports, and now it is actually being increased again because we want to disincentivize imports and accelerate local manufacturing. So this helped a lot, and that led to a lot of cities implementing. So this is just, if you can get to the next slide, please. So these are just dots showing where the implementation was. The first round was only focused on 10 locations, and this in the second round we see many more cities adopting. I won't go through all of them, but the point is to show that because there is more standardization and more government proactive government support, there is much more uptake in the second round of procurement. And then if you go to the next slide, what we see now is that, so now we also understand that because of so many cities adopting it, there were really small scale procurements also, like 25 buses, 50 buses in a lot of cities, which was not optimal because you need to have charging infrastructure irrespective of whether you have one bus or 100 buses. So there is a lot of scale economics you can derive by concentrating procurement. So in the next round, for the next 3 years, Government of India decided to procure buses in the 9 cities mentioned here, and have a large-scale procurement, at least 500 to 1,000 buses in these cities, so that we can actually have economies of scale. But if you go to the next slide, what we saw is that in the previous round of procurement, there were a lot of learnings we can still derive. And I've highlighted this because these may be applicable even for Indonesia, because as you decide on your procurement strategy, so these are some things that are generic in nature, which may be applied even in your context. So firstly, what we saw is that across both rounds of procurement, the number of bids attracted by cities were lesser. So a lot of times there were 1 or 2 bids only, and not more than that. Even though there are 6 to 7 bidders across the country, in a particular city, there were only 1 or 2 bidders. And the other key thing is the cost. Everybody highlighted previously that cost is a key barrier for electrification. What we see is that even at the current rate of subsidy Indian government has, so the gross cost contract cost quoted per kilometer is actually 15 to 30% higher compared to an equivalent diesel bus. And it's not a static thing. So it varies across different bus types. For a 9-meter bus, it's different. 12-meter bus, it's different. And also it's different between different cities. So for the same spec, there is almost 60 to 80% variation depending on the type of bus on the per kilometer cost quoted. But the good news is that with every round of procurement, the costs are declining. So for the same tender, if you procure 6 months later, 1 year later, you will actually have lesser rate. But doesn't mean that you don't procure the vehicle. It's just that the vehicle costs are falling rapidly. So over a period of time, you will see a reduction in cost overall. But the other thing is, even at any given point of time, the bankability of the contract is quite key. So at any given point of time, the variation is also partly because of the bankability of the contract, which is leading to these variations. I'll explain that a bit more in the next slide. So if I showed in the previous slide, we just had the absolute cost. Here we get into the split. So what we did was at UITP, we have actually looked at the quoted cost for a few cities and worked backwards on what is leading to a particular cost. So the interesting thing we identified is that about 37% of the total cost of procurement is the capex cost, which is 27% is the bus cost, the charging infrastructure cost, and also the second battery, because the contract is for a life cycle of 10 to 12 years. There is a battery replacement involved, and so that is built into the contract upfront, of course. So that leads to a lot of cost on capex, and about 10% within the 37% is the financing cost itself, because it is a capex intensive thing, and then the private operator needs to source capital from commercial lenders. So that leads to significant cost also. Around 30% is almost fixed cost, like the staff cost or the insurance cost. These are things we can't really change. But the other thing is around 7% is the penalties which the operators are building in. So in any typical contract, there are penalties for non-performance. What bidders are doing is that they are building that into the cost of procurement and quoting it to the city, which can be avoided by a bit more flexible SLAs. The other thing which is not seen in the cost is the risk associated with any given contract. So for a similar contract document, different cities have different rates, like I mentioned earlier, because of the service provider's assessment of how good or how bankable the city is, whether the city can actually pay on time or not. So what we observed is that this can be addressed by better designing of the model concession agreement, and then there are also national level instruments you can put in place to reduce the bankability risk and actually reduce the cost overall. If you go to the next slide, so here I'll just wait for the next slide. Yeah. So now we go into the procurement aspect. So no, the previous slide, please. Yeah. So there are financial incentives, then there is the overall cost understanding, and then we go to the procurement, which is the next slide. So there are different components of procurement. There are different levers you can play around with to make sure that you actually have much more bidders participating in your procurement exercise and also drive cost efficiency. So the 4 big buckets under which you can club them is, first is the eligibility criteria, which is the most important thing because that is what ensures more participation. So there are different business models within a given gross cost contracting model also. So like Anthony was mentioning, who owns the asset, who does the operation, who finances it. So even though there is one gross cost contract given out, what we observe is that in different cities, there are different joint ventures being formed, where a financing entity leads the bid, or the service provider leads it, or an OEM leads it. So if you make it flexible enough, so there will be more participation. And and that will also encourage different business models within the larger business model you identify. The second most important thing is the physical and financial obligations. So the obligations include things like what is the city committing to? So things like who is making the depots available? Is the power infrastructure provided by the city, or the service provider has to source it? Sometimes the charging infrastructure also is provided by the city. So all these needs to be clearly mentioned in the contract. So you can identify whichever method. So that leads to some cost. But if you don't have clarity on the contract, that actually leads to a bigger cost because the service provider will assume for the worst case scenario and quote accordingly. So this is quite important, and cities need to have a partnership approach for service delivery, because the service provider is your partner and not somebody taking, just like a vendor giving away a bus to you and leaving. So it's a 10-year contract or a partnership. So that's quite important while defining the obligations. And the payment timelines. Yeah.
Yeah, we still have 3 minutes for your presentation. Thank you.
Okay. Yeah, the payment timelines, penalties. So they need to be firstly clear, and the shorter the timeline of payment, the better, because there is lesser working capital requirement, and the service level agreements based on which penalties are defined needs to be clear, and the city needs to have the capability. And then the technical specifications, of course, need to be clarified. So yeah, so that's fine. If you go to the next slide. Next slide, please. So we have all the details. We identified which component affects how much of this, but I'll skip that. We'll go to the recommendations. We have 3 sets of recommendations. One is to reduce costs, which is mostly to standardize the procurement across cities, and then establish a loan guarantee, bank guarantee mechanism. Like I said, 10% of the cost is financing cost. So Government of India is now working with different entities to establish this mechanism to have financing and then a loan guarantee also. And then the payment guarantees are quite important because that's impacting cost a lot. The other very important thing is to look at the city's readiness also, because there is so much variation when it comes to an electric bus. Cities need to be putting in a lot of effort in understanding things like what routes and what technology, and understanding contract management. That in itself is a very, very important and complicated aspect the cities needs to be built with. The other key enablers like having a city level viability gap funding mechanism, and also engaging the electric utilities quite early is also quite important. And if we finally conclude overall, if you go to the next slide. So what we see, I'm stating the obvious, it requires everything to change. The technology, business model, operations, everything will change. So the financial incentives at the center are quite important, because that gives a direction to the industry and also standardizes procurement, so which is quite important. Then the procurement specifications itself, the bankability risk within the procurement is the key. And then the number of bids is also quite important. So people keep focusing on the cost, but costs are a second order issue. The first order is attracting number of bids, and that depends on the contract size, the preparedness of the authority, service planning, operations planning, etc., which is quite important. And finally, capacity building is very, very important also, because the cities in charge are the ones driving all of this. And finally, so if you go to the next slide, I'd just like to summarize what UITP India is doing. So we are working on some of these aspects, and we are also looking at performance evaluation of electric buses already deployed, and also looking at rural and intercity buses. And we are thankful to all the funders mentioned here who are supporting our work. Yeah, thank you.
Yeah, thank you very much, Ravi, for your presentation. And we will have still another Q&A session after the last presentation for the second module, Ravi. So please stay with us. And then for the last but not least, now we have a case study from Singapore that will be delivered by Ong Weng Ming. So I will introduce him first. So he is from Singapore Land Transport Authority, Public Transport Group. His work focuses on planning, strategizing, and adoption of cleaner energy buses and charging infrastructure for Singapore to achieve 100% cleaner energy bus fleet by 2040. And he has 6 years of experience in land transport and has been involved in a wide range of land transport projects, such as the rollout of passenger information system on board buses, trialing of mobility assistance for the visually impaired and special users, project for an inclusive public bus system, and the rollout of Singapore's first 60 units of electric buses, and supporting charging infrastructure. Hello all, we have 15 minutes for your presentation. I hope you can do less than that. So the stage is yours.
Before diving into the topic, let's useful to get some context on the environment that LTA as the land transport regulator operates in. In Singapore, we are a densely populated city-state with many constraints that is very similar to other cities, such as the land constraint, aging population, and manpower crunch. In addition, in consideration of the rising expectations by our commuters to be more inclusive, environmentally friendly, and land transport, it's important that we continuously adjust our approach for public bus transportation systems. These slides give some background information of the overview of Singapore's public bus network. You can see that the public bus network in Singapore plays an integral role in Singapore's transportation system. We have an average of 4.1 million average daily bus ridership and up to 360 bus routes since 2019. Singapore bus industry has come a long way since 1960s, where the industry was initially fragmented with low-level regulation of bus industry, and the responsibility of bus service assets solely lies with the bus operator. Since then, the government, we have started intervening to ensure for the development of the bus industry, to ensure that the bus industry is able to deliver quality bus services and standardization of all assets. LTMP 2008, which is our land transport master plan, have marked a significant policy change to restructure the entire bus industry for greater contestability and improvement. With a stronger demand for quality bus service and bus service capacity, we have increased our investment on bus assets and partnerships with the operators and suppliers to make this happen. This culminated with the implementation of the bus contracting model in May 2016. I think this is the key point for all the different cities, that the role of the transport authority or agency in the tender process and adoption of electric buses or cleaner energy bus is very dependent on the adopted public bus model in the city itself and the transportation objective of the different cities. For Singapore, with the ultimate goal of having the industry structure to be more responsive for commuter needs and to be more competitive in the industry, we have structured it that the government will own all the bus infrastructure, buses, and onboard systems, at the same time retain the fare revenue. At the same time, the operators will be instead pay a fee to operate the services. By doing so, we'll become the central planner across all modes of public transport, and we'll be planning and purchasing all the different buses by open procurement process. With this, building on our past achievements, we have come out in recent years. We've come out with the Land Transport Master Plan 2040, which built on which we have consulted the public extensively and received the feedbacks of over 7,000 Singaporeans to see how we can better develop the public transport system for tomorrow. We have come out with 3 key thrusts for the LTMP 2040, focusing on 20 minutes town and 45 minutes cities, which improve the connectivity among all our regions. Transportation for all to be more inclusive and accessible for different commuter groups. And lastly, healthy life and safer journeys, where we look to be more sustainable and adopt cleaner energy vehicles, such as electric buses. As announced through the LTMP 2040, we have announced that we'll be taking the lead to build a cleaner transport system and will commit for 100% cleaner energy bus fleet by 2040. As such, all new bus purchases from today onwards will be cleaner energy buses, and all our new bus infrastructure will be designed and built to support cleaner energy buses, such as electric bus. Sorry, I think the slides here, there's some issues with the slides. I'll just speak through it. Hey, the shift towards a cleaner energy bus requires a paradigm shift for both implementation and operational approach. This is due to e-buses, chargers, and operations having to be integrated as a component of a system. As such, there are many considerations for e-bus operations in Singapore, such as the infrastructure requirements, especially the demand for charging power is high. So there is a need to ensure that bus infrastructure and grid is able to support the charging operation of electric buses. The operational range of e-buses is also limited based on current battery technology of up to about 250 km on average. This does not fulfill all our public bus operation needs, as our public bus operates can go up to 400 km per day. And the suitability of e-bus operation in Singapore, such as the climate, indicatively, the energy consumption for air conditioning for Singapore is about 40% of the energy consumption of a bus. Because of all these considerations, for our initial step towards electrification of public buses, we procured 60 units of electric buses and charging facilities and have subsequently awarded these to 3 different suppliers to allow LTA to gather the different models of operational and vehicle data of different models of electric bus and charger solutions, with the aim to help us better understand what is the best possible solution technology that we can implement going forward. For these 60 electric bus pilot, we have committed significant resource into purchasing the buses and the associated chargers, and we have looked to reduce the cost, to minimize the cost by checking which are the possible bus infrastructure we could test the e-buses without having to do extensive retrofitting and enhancement to the power grid. As mentioned earlier, we have awarded these to 3 different suppliers, and our tender specification for our bus buys and chargers, which is similar for all our other procurement plans, are outcome-based to ensure that the delivered product can achieve LTA's desired outcome and are fit for purpose. This also encourages suppliers and manufacturers to innovate and introduce new technology that can help to achieve the desired outcome. One of these things is that we are continuously reviewing our tender specifications and to always ensure that our tender specifications are updated to account for the latest technology. As one always says, today's breakthrough is tomorrow's standards. And this allows us to ensure that each tender that we call for the buses and chargers are fine-tuned to meet our operation needs. For these 60 electric buses, we are distributed and to all the suppliers, all the public transport operators, to ensure that all the operators are given a chance to familiarize and experience operating electric buses and charging infrastructure in Singapore. This helps to ensure that our partners, the PTOs and suppliers are ready for the smooth transition for electric mobility. LTA will be monitoring the performances of the e-buses through the key parameters such as the energy consumption of the buses, and also checking with the bus captains to get their feedback on operating electric buses. So why 3 suppliers for 60 units of e-buses, which is why this number of buses? We have chosen 3 suppliers is to ensure that we're able, like I mentioned earlier, to trial different charging solutions and gather multiple data points from the different suppliers and different type of buses, such as the 3-axle double-deck electric buses, opportunity charging pantograph electric single-deck buses, and the plug-in charging single-deck e-buses. Through these different technologies, we're able to better calibrate our approach for future cleaner energy buses and charging infrastructure. This has also allowed the industry and the operators to familiarize with the different charging operations and e-bus technology to better prepare the bus captains, technicians, and the workforce for the transition to operate these buses. Furthermore, we have procured 60 units of buses among 3 suppliers to ensure there's sufficient quantity of buses that the operators can operate on and trial deploy on. To give some context, for Singapore, we have a mix of feeder routes and trunk routes. And for a feeder route service, it's generally about 8 to 10 buses on the route, and for trunk routes up to 30 buses. So having 20 buses per supplier will give us the flexibility to operate all the buses on a single route, to stress test the bus, and to get better operational data. Okay. This slide here gives the overall information of all the 60 units of e-buses that were procured from the suppliers, with a mix of plug-in charging bus, which are the Yutong and BYD bus, and the Stamos bus, which is the opportunity charging pantograph electric single-deck bus, which have been just recently launched. For our current e-bus pilot, we are testing both overnight charging and opportunity charging with pantograph. We understand there are other technologies such as the wireless induction charging that's available in the market. However, we have made the conscious decision to pilot overnight charging and opportunity charging, as compared to contact charging. Induction charging has a lower charging efficiency. Prior to the pilot, we already decided that overnight charging will be plug-in chargers, whereas the opportunity chargers will be pantograph charging at the interchange. for this opportunity charging for Pantograph, we only piloting it at the interchanges due to the significant cost if we are choosing to deploy this along the route on the bus services. Besides the implementation of and operation of the clean energy bus fleet, it's essential that as regulators, LTS ensure that the industry and the workforce are prepared and familiar with the technology for a smooth transition towards electromobility. For the procurement of the electric buses, we expect into our tender, the suppliers are to provide training and expertise support to the operators to ensure that the bus captains, technicians, and the service operators are trained and prepared to operate these electric buses and chargers. In tandem with the push to adopt new e-bus technology, we also work with SG Bus Academy to engage the industry stakeholders such as our union, bus suppliers, operators, to continually develop and conduct new courses to ensure that our workforce are prepared to adoption of this new technology. We also have multiple channels of engagement with our suppliers and our partners, like the public transport operators, for them to highlight their concern, challenges, and suggestions that we could adopt to help improve the e-bus and our adoption of clean energy buses. This allows us, the regulators, to work closely together with the industry to ensure a smooth transition for electric buses.
Excuse me, we still have around 2 minutes for your presentation. So
okay.
Thank you.
So just last few slides. One thing to highlight a few challenges that we have faced for this pilot is that at the start, the new e-bus suppliers are unfamiliar with the local requirements, such as the buses have to last for 17 years statutory lifespan and to meet Singapore operation requirements. To resolve this, we work closely with suppliers from the start of the design of the buses to the delivery of the buses, and have implemented multiple stages of quality control inspection to ensure that the bus production meets our needs. As mentioned earlier, due to the limitation of existing infrastructure to support electric buses, we have identified existing bus infra that could have enough power from the grid to support e-buses to minimize the cost. In terms of the high passenger loading demand, we have worked to identify routes with lower loading data from passenger data, and will continuously monitor the bus operations and to take necessary action if there is an issue with crowding. The last slides will give an overview of the e-bus performance to date. In general, our e-buses have performed well within expectations. The daily mileage of the electric bus can operate from 250 km to 290 km. Our energy consumption range from 1.1 to 1.2 kilowatt hour per km for the single deck bus. This translates to about 50% energy savings and reductions in CO2 emissions for our buses. Through feedback from the bus captain, it's been very positive. The bus captains highlighted that the operating e-buses is a lot easier because they are smoother and more comfortable. Additionally, because e-buses have better torque, they are more responsive during operations. Thank you. That's all for my sharing.
Thank you very much. And after this, we will directly go to the discussion session. Okay, so for the first question, I will address this one to Anthony. So the question is, how can the government provide incentives for third-party service providers to participate in the ecosystem, given the high uncertainties in the industry? So what can we learn from other cities that already implement these schemes?
Yeah, that's a very good question. So, we've talked during the past hour and a half, we talked about subsidies, but I don't really want to talk about subsidies because I think, it's the basic requirement when you want to put together a project is to make sure that it is financially viable, right? So that's work that has to be done to make sure that, you do your financial modeling and you do your due diligence, making sure that when you offer a project to tender, it's a project that is financially viable. But I would say that aside from that, one of the major things that we see today, or the major barrier, I would say, to large-scale participation of private actors is the lack of guarantees. And even when you have a project that is financially viable, with a very steady revenue stream, there are still major concerns that private investors have when they get into a project like that, depending on how the project is structured. And I chose for this presentation not go into the details of how the ways by which these projects can be structured. And I think Jenny went into a little bit more detail with the project Santiago, but the need for guarantees is something that the government can use as a leverage to bring private capital. It's something that needs to be structured into the project, and there's multiple ways to do that. It doesn't have to cost money, and I think that's the message to convey. A good way to offer guarantees is to have a fund dedicated, to have a pool of money dedicated to backing the project. So in case something happens, in case the project runs out of money, in case the revenue stream disappears, and we've seen, we just saw it with COVID, is that the revenue stream can disappear, then there is an amount of money that is dedicated for that. So it's not money that necessarily has to be spent. It's a reserve. It's a guarantee. So there's multiple ways to do that. But if I were to say, where does a city need to work, and what is the amount of work that needs to be done, it's on that. It's on the guarantee. It's on figuring out what would make private sector actors confident that payments will be there, payments will be delivered, payments are independent from passenger demand, payments are shielded from anything that may happen to the operator. And it's countless occurrences of operators going bankrupt. Investors have to be protected from that. So government guaranteeing those payments, government structuring tenders that make investors feel confident, that is, I think, where the work has to be done.
Okay, thank you, Anthony. So it's the guarantee to protect, right? And then to the second question, I will address this question to Jenny Ramirez. So this is the question from Aditriat Mojo. So the question is, does the concession contract only between MTT DPM and Medbus, or is it a concession contract between a consortium, Medbus, Enel, and also BYD, with Medbus as the bid leader? And maybe this is another follow-up question from Gita Fajar, still related to the question. So what will be the contract requirements for the new business model, Jenny?
In the case of Medbus, there are three more operators in similar situation. They have a contract with the authorities to operate at least for 1 or 2 years more. And the other three operators are ending now the contract with the authorities, and the authorities is running now on a tendering process to replace them, and the tendering include a lot of incentive for battery electric buses. In the case of Medbus, in the specific question, Medbus has a contract from the year 2006 with the authority for the operation. They still left a couple of years for operation. And the utility that is called Enel X, that is providing the buses and the charging infrastructure, they have an agreement with the authorities that the buses that are running with Medbus will run in the future after the contract of Medbus. When the contract ended, in a couple of years more, the bus is still running with another operator. That is one of the key issues that Anthony mentioned, how the authority give conditions for the investors to minimize the risk. That's the case for that. And one key issue in terms of in the incentive for the tendering process now, that is for 2,000 more buses, and where diesel Euro 6 buses are competing with battery electric buses, all those are 12-meter buses, is the period of the contraction of the contract. If you are running battery electric buses, you have 7 years contract plus 7 years more if you meet some requirements. In the case of diesel buses, you have a less period for contract, 5 years, and with 5 years more. That is a general description of the situation of these operators in Santiago.
Okay, thank you very much, Jenny, for your explanation. And then for the next question, this is for Ravi. So Ravi, based on your recommendation, 3 specific things that we need to focus on are bus procurement. From your perspective and experience, which one is really important for e-bus procurement in Indonesia context?
So what are the specifics within the procurement you are saying?
Maybe could you recommend like what the important aspect of e-bus procurement in Indonesia context? So I think the question from our attendees is quite general here, but maybe they want to hear about your specific recommendation on procurement strategy.
Yeah. Sure. So first thing to define is the policy requirement on whether you are okay with importing buses, or do you want it to be mandatory to make it to manufacture in the country. So to drive costs down, I would recommend going for importing vehicles in the beginning and test them out and then figure out what is working, what is not. So the FAME one, what we had was to actually allow a lot of imports also, so which helped actually build the ecosystem. We had 6 different manufacturers operating in India. So that would be one. The second thing, of course, is the contractual obligations. So to have a very clear roadmap for a 10-year things. A lot of times, the mistake Indian cities did was they look at today's operation and define contractual things. I mean, there's just one variable called the assured kilometers of payment per day. So that varies the cost a lot. So when you define a kilometers per bus per day, you need to identify your operating conditions and then think 10 years ahead. In 10 years, based on the upcoming congestion and everything, how can I assure, or what amount of kilometers can I assure? So identifying that requires a bit of planning and identifying depots, routes, etc. So I think that would be the second thing. The third thing, standardized procurement. If you have multiple cities going, and then within Jakarta itself, if you have 2-3 procurements, having a predefined tender document is quite important. So that will ensure that actually just a corollary to that is that a lot of times in Indian cities, not a lot of times, but some cities were very clear on what exactly they want. And they didn't get the bidders because that was not fitting into what the bidders were offering. On the other hand, there were many cities where they just floated a draft tender and then figured out at the pre-bid meeting whether what they have floated is working out or not. So we don't want either end of the spectrum. We want somewhere in the middle where you have a draft set of specifications and have actually a month or so of pre-bid meetings and engagement with the bidders to understand what is the local context and what are they comfortable with on the specification. So that flexibility before issuing the contract is quite important.
Okay, thank you very much, Ravi, for your 3 recommendations for the procurement strategy in Indonesia context. And then the question next is for Onweming. This is from Rahul Gupta. The question is, in Singapore, how is the e-bus maintenance responsibility defined given they are owned by LTA? Are there any specific provision to ensure operators adhere to the maintenance requirements?
Hi. Okay. As what we shared earlier, right? Under Singapore context, right, the operators are contracted to operate and also maintain the buses. This will include the e-bus maintenance responsibility. For LTA, we come in to prescribe the outcome-based regulatory requirements, such as the maintenance standards and requirements that you should follow. In addition, we ensure that the suppliers are trained by the operators are trained by the suppliers to know how to maintain and operate the electric buses and chargers. We regularly conduct audits on the operators to ensure that the maintenance of the buses meets our requirements and standards. That's all.
Okay. Thank you very much. And then next, this is, this is another question from our audience for Onweming also. The question is for Mega Kusuma Ningkatma. The case of Singapore, where the assets and infrastructure are owned by government, that can accelerate the deployment. But in the case of Indonesia, where the government is not willing to invest to own the infrastructure, how to advocate and convince the government for that to succeed the deployment and hindering high-cost investment for operators? Thank you.
Okay, I think like what we highlighted that this is very subjective to each of the cities and countries where they operate the public bus industry. There's no clear cut what is the best solution, and it's really to adapt each of the policies and solution to each countries and cities. For get-go, I think for LTA is easier because under the bus contracting model, we do own the assets, so we can dictate it. Because our objective is to provide a more sustainable public transport system and better services in Singapore, which I believe is the key role of all the other regulators in other cities. However, I think there are other contexts, like you say, the high cost itself. And for that, what Singapore have done is that in doing the evaluation of our tenders and our procurement, we will look in terms of the entire life cycle cost of the buses and charges to also include what is the operation savings and benefits over the entire lifespan. I think by going that, you can actually have a better picture overall if adoption of this electric bus, will it be beneficial for the city? Because it's very widely known that electric bus has higher fuel savings compared to diesel bus. And that could be a shift the needle for the government to make the decision whether they want to shift to deploy electric bus earlier.
Okay, so it's back again to total cost of ownership, right, for the e-buses?
Yes.
Okay, thank you very much. I think that's the end of our discussion for the second module. Thank you very much for all of the panelists. Ladies and gentlemen, we already discussed a lot today, and in this second workshop, we have talking about the selection of e-buses technology and also the charging infrastructure planning, where there are a lot of factors that we need to consider when we are planning the whole ecosystem for e-buses, yeah, not only for route, charging speed, customer behavior, and it's really micro market choice for us to make the decision, yeah. It's really depends on the region. And then in the second module, we already discussed about the business model and the procurement, how a great business model can reduce risk or to spread the risk over all stakeholders of EV space, and that can increase the bankability of the projects. So that was our discussion for today about technology selection and business model on e-bus deployment. And now I would like to invite Rahul Gupta as a senior urban transport specialist at the World Bank to give a closing remark to conclude our discussion. To Nupur, the floor is yours.
Thank you so much, Vanya. Assalamu alaikum. Good morning, good afternoon to all of you. I want to start by thanking everyone for this extremely productive workshop where there was very rich knowledge exchange. We had a very elite panel of experts sharing their insights and their knowledge, including experience from global case studies on the deployment of electric bus technology and business models and the pitfalls that are inevitably engaged. Let me just continue. So
yeah, sure.
Both the DGLT, DG and Pamanto highlighted the importance of the e-mobility agenda in Indonesia, how the severe pollution problems lead to the need for adoption of cleaner technologies, how the government of Indonesia is already investing in a strong policy framework and agenda for the deployment of e-bus technology, the potential for urban bus fleets in this agenda, and also Pamanto highlighted the development of an ecosystem within Indonesia and an industry around batteries and e-mobility, which will help reduce costs significantly, given that Indonesia is such a large market. And we had Ben Ibergen from the World Bank, Practice Manager East Asia region, highlighting the importance of e-mobility globally, and specifically for Indonesia, going forward. Our first session was on technology selection, and I think we had some very good presentations from Rahul Bhaktia, enumerating the different technology types that are available for e-buses, and how Indonesia has jumped to the pure electric BEB technology option, which makes a lot of sense, bypassing the long trajectory that the early adopters in Europe and US took, and also how the lithium-ion battery technology, there are nuances, and it gives different kinds of caters to different needs based on range, etc., which must be factored in when deciding the battery type most suited for the type of deployment. On charging infrastructure, we had very interesting presentations from Rahul and Vishal, which pointed to the whole number of parameters that needed to be looked at, including route type, geography, the customer side, which needs to be looked at in deploying the strategy, and how depot charging and opportunity charging are the two main types of charging options emerging going forward from a transit perspective. We had interesting case studies of the Transjakarta deployment, which is moving forward very quickly. It is proposed that all new bus inductions, e-bus inductions by 2025 would be of electric BEB type, and they are already advancing on their pilot and should have buses arriving by next month. And they've already planned out how that deployment would happen over the next 10 years. In Bangalore, with Ray's insightful presentation, we saw how passenger loads were a major important criteria in defining the fuel, the energy consumption, and how the AC did not really have a significant impact in terms of the fuel consumption performance. And he also made an interesting point about how starting out transit agencies might want to look at a structured way of identifying their deployment strategy, looking at the depot locations, the buses that run from those depots, the routes that are plying, and trying to optimize the identification and deployment, starting out with those routes and buses which can depend solely on depot charging. I think that was quite an interesting point that he made. We then moved on to our next session on business models, which is again an extremely interesting area in the area of e-bus deployment. There's been a lot of activity here, and we started with a very interesting presentation from Anthony Courageous, who highlighted that this move to look at alternate business models is really driven by the fact that the environment has changed with e-mobility, and how that has its own peculiarities and therefore risks that it introduces into the environment. And to name a few, is the high capex that we see, the weak capacities typically at the urban local level, the technology uncertainties that have to be dealt with. So there are a number of risks that have led to the need for looking at alternate models from just the pure bundled contracting model that one saw with the ICE engine, and a pointer to perhaps start looking at unbundling some of those contracts to split ownership and operation to make these more viable and easy to balance the risks all around. We saw in the Chile model, the Santiago model that Gianni Ramirez shared with us, that they have moved towards a split model where the ownership is not with of the buses and the charging infrastructure is not with the operators. And interestingly, they have a utility company which has played that role of being the asset manager and also the utility, the charging and the energy service provider. So it's quite an interesting model. India has followed a slightly different model. A lot of it is driven by the national schemes and programs that are driven from the top. And these have really precipitated in large part the developments that we are seeing. There is a significant subsidy or a VGF, as you may call it. There are also efforts to move towards a standardization of the business model and also the procurement documents to bring clarity and transparency in that whole process, to be able to achieve the kind of scale that they are looking to achieve. And I think these are very important takeaways also for Indonesian cities and the government of Indonesia, that how government policies and financial support are crucial in the initial years to kickstart that whole process, and how standardization can help provide the right market signals to OEMs, to service providers, a number of stakeholders, and set the playing field for moving forward faster. And then we had the Singapore experience shared by Mr. Ming, and it is interesting to see that they have also moved incrementally to in their e-bus to a split model, where the buses as well as the infrastructure is owned by the government. And as they are moving towards this whole e-mobility agenda, they have fairly ambitious targets of moving entirely to zero emission technology by 2040. And in that regard, they have started with this 60 buses that they've already deployed on the ground. And they are using also a very practical and smart approach of having multiple operators, different models of buses, to try and understand what works and what doesn't as they move forward and will need to achieve scale over the next few years. And they're using this as a learning ground to understand what the performances are, how the performance of the different models and routes and buses is playing out, and how they need to tweak their strategy, which is an extremely important takeaway also for Indonesian cities as they move forward on their ambitious targets and programs of the government of Indonesia to make this a reality. So it was all in all an extremely rich exchange. I want to thank all of the speakers for making the time to engage with us in this workshop and share their knowledge. I also want to really appreciate and thank the participants for their active participation, for sharing and raising questions, which has made this even a more interesting discussion and exchange for all of us to take forward. And I would like to thank ITDP and ICCT for organizing this. They've done a wonderful job. I especially want to thank Vanya for doing an excellent job with the moderation as ever. This is our second in the series of workshops that the World Bank has undertaken, and we will be coming back with more. And finally, I would also like to acknowledge the support of MOLO and ESMAP trust funds for the bank to undertake this important study for Indonesia. Thank you so much.
Thank you very much, Nupur, for the closing remarks and the conclusion. It's awesome, everyone, to have such a fruitful discussion and amazing insights, especially on IPA's deployment for Indonesia. I hope that this will help us again to accelerate our deployment on e-buses. So again, we would like to give our highest appreciation to all speakers. Thank you very much for giving your time here and also your experience, your knowledge. And for all of the participants, ladies and gentlemen, thank you very much for joining this session, this workshop, and for giving us the best discussion, because you participate actively with us here. And also thank you for all the parties that have been supporting this event from the beginning. And I'm Vania Fitrianti Herlambang. See you in the next event.